Welcome to the Python Data Analysis and Visualization course, where our goal is to help you experience the techniques of analysis and visualization and make it easy to learn for people from every walks of life. Let's meet the team who played a role in researching, designing, and creating this course. We have enhanced the learning experience by explaining key concepts visually. We will have a Capstone project at the end of the course that will let you learn all the concepts in one place and in one go. The starting sections are a refresher to your memory as it covers the basics of programming. Then, we will switch gears to web scraping, Numpy, and Pandas modules to perform exploratory data analysis. In the second last section, we will perform data visualization. For a data scientist, data analysis and visualization are the core skills, and so it is important to study and learn key concepts, such as the use of pandas when dealing with series and data frames, Numpy for Python, arrays, Matplotlib and Seaborn for visualizations, and functions to perform data analysis. And of course, Python to perform all the operations. Here are some of the companies requiring data scientists to fuel their day-to-day operations and critical software development needs. We look forward to having you join our course, and we promise that this course will help you build your foundational coding skills in Python data analysis and visualization. That will help you make your resume stand out and demand a competitive salary in the marketplace. This course is designed for beginners, anyone who wants to get exposure of data sciences techniques, or an individual who wishes to switch career as a data scientist and looking for a jump start. So, what are you waiting for? Get enrolled in this course and step into the world of Python data analysis and visualization.
Hi friends, and welcome to Python Data Analysis and Visualization course, a course that is designed in a very easy and interesting way. In this course, you will learn from data analysis to data visualization in a series of easy to follow lectures. So let's get started. In this very first section, you will be introduced to the foundation of data analysis and Python computer language, and you will learn why Python is necessary for data analysis and data visualization jobs. So what is data analysis and why it is important? Before getting started with data analysis, first there is a need to know what is data science. We have massive amounts of data about many aspects of our lives and simultaneously an abundance of inexpensive computing power. Shopping, communicating, reading news, listening to music, searching for information, all this is being tracked online. As most people know, your smartphone is building up a record of your location, and social media is creating huge amounts of data. It is not internet data, though. It's finance, the medical industry, pharmaceuticals, government, education, retail, and the list goes on. These data are answers to many questions as they have hidden values and patterns in them. So what is data science? Is it new, or is it just statistics or analytics rebranded? Data sciences is the solution to clear up any uncertainties. Data science involves many methods to analyze and extract the knowledge it contains. Businesses generate and store tons of data every single day, but what happens with this data after it's stored? The short answer is the most of it sits in repositories and analyzed, as the data can hold valuable insights into users, customer bases, and markets. The question is what data analysis is and how it is carried out. Data analysis is the process of evaluating data using analytical or statistical tools to discover useful information, from refining data to visualizing it after careful analysis and transformations. It plays a very important role in formulating important business decisions by analyzing trends and reviews to increase sale of products, improve business processes, and to create a strong bond with customers. Some examples include: how can we reduce production costs without sacrificing quality? What are some ways to increase opportunities with our current resources? Do customers view our brand in a favorable way? Data analysis is broadly classified into 5 categories. The first one is data text analysis. The second one is statistical analysis. The third one is diagnostic analysis. The fourth one is predictive analysis. And last but not the least, prescriptive analysis. Consider an example of detecting keywords and phrases that appear most often in your data. This is text analysis. Text analysis tools are often used to unearth valuable insights in social media, conversations, survey responses, online reviews, and more. Text analysis allows companies to automatically extract and classify information from text, such as tweets, emails, support tickets, product reviews, and survey responses. Popular text analysis techniques include sentiment analysis, topic detection, and keyword extraction. Statistics are applied every day in research, industry, and government to become more scientific about decisions that needs to be made. Look around you, from the tube of toothpaste in your bathroom to the planes flying overhead. You see hundreds of products and processes every day that have been improved through the use of statistics. Once you have collected qualitative data, you will have a lot of numbers. It's now time to carry out some statistical or descriptive analysis to make sense of and draw some inferences from your data. How can statistical analysis help in the real world? In a healthcare setting, for instance, say that an unusually high number of people are admitted to the emergency room in a short period of time. Statistical analytics tell you that this is happening and provides real-time data with all the corresponding statistics that include data of occurrence, volume, patient details, and etc. Diagnostic analytics takes descriptive data a step further and provides deeper analysis to answer the question, why did this happen? Often, diagnostic analysis is referred to as root cause analysis. In the healthcare example mentioned earlier, diagnostic analytics would explore the data and make correlations. For instance, it may help you determine that all of the patient's symptoms, such as high fever, dry cough, and fatigue, point to the same infectious agent. You now have an explanation for the sudden spike in the volume at the ER. Predictive analytics takes historical data and feeds it into a machine learning model that considers key trends and patterns. The model is then applied to current data to predict what will happen next. It allows organizations to become proactive and anticipate outcomes based upon the data and not on assumptions by considering various factors along with descriptive and diagnostic analytics. Back in our hospital example, predictive analytics may forecast a surge in patients admitted to the ER in the next several weeks. Based on patterns in the data, the illness is spreading at a rapid rate. Now that you have an idea of what will likely happen in the future, what should you do? It suggests various courses of action and outlines what the potential implications would be for each. Back to our hospital example. Now that you know the illness is spreading, the prescriptive analytics tool may suggest that you increase the number of your staff on hand to adequately treat the influx of patients. Data analysis is the process of evaluating data using analytical or statistical tools to discover useful information. Number 1, setting up data analysis goal. Number 2, begin collecting data from sources. Number 3, clean through unnecessary data. Number 4, data exploration. Number 5, data modeling. Number 6, visualization. And number 7, interpret the results and apply them. Data requirements definition establishes the process used to identify, prioritize, precisely formulate, and validate the data needed to achieve business objectives. Data collection is the process of gathering and measuring information on variables of interest in an established systematic fashion that enables one to answer stated research questions, test hypotheses, and evaluate outcomes using standard validated techniques. A researcher can evaluate their hypothesis on the basis of collected data. Data preprocessing is a data mining technique that involves transforming raw data into an understandable format. Real-world data is often incomplete, inconsistent, and/or lacking in certain behaviors or trends, and is likely to contain many errors. Data preprocessing is a proven method of resolving such issues. Data cleansing or data cleaning is the process of detecting and correcting corrupt or inaccurate records of dataset, tables, or databases, and refers to identifying incomplete, incorrect, inaccurate, or irrelevant parts of the data and then replacing, modifying, or deleting the dirty or coarse data. Data interpretation is the process of making sense out of a collection of data that has been processed. This collection may be present in various forms like bar graphs, line charts, and tabular forms, and many other similar forms, and hence needs an interpretation of some kind. Data visualization is the graphical representation of information and data. By using visual elements like charts, graphs, and maps, data visualization tools provide a visual summary of information to see and understand trends, outlines, and patterns in data. Data visualizations make big and small data easier for the human brain to understand. It shows the relationship among the represented data. Tools such as SPSS and different languages such as R, Julia, Python, etc. used for this purpose. We will discover the data analysis process using Python. Now we will understand why Python is necessary for data analysis, or why Python is a good candidate for data analysis in the first place. Before getting into the nitty-gritty of data analysis, a business will need to define why they are seeking one in the first place. This need typically stems from a business problem or a question. Some examples include: how can we reduce production costs without sacrificing quality? What are some ways to increase opportunities with our current resources? Do customers view our brand in a favorable way? Now the organization can find the hidden patterns from the data and analysis. Python has long been known as a simple programming language to pick up from a syntax point of view anyway. Python also has an active community with a vast selection of libraries and resources. Python is lightweight and efficient at executing codes, but it is also multifunctional. Also, Python can support object-oriented, structured, and functional programming styles, meaning it can find an application anywhere. Data science involves extrapolating useful information from massive stores of statistics, registers, and data, and Python is capable of providing best results with minimal coding. Let's get started to develop the understanding of data wrangling and data cleaning, the important concepts that are necessary to be performed before any wonder can happen. Data wrangling involves processing the data in various formats like merging, grouping, concatenating, etc. for the purpose of analyzing or getting them ready to be used with another set of data. It further includes data aggregation, visualization, and training models for predictions. When combining multiple data sources, There are many opportunities for data to be duplicated or mislabeled. If data is incorrect, outcomes and algorithms are unreliable, even though they may look correct. There is no absolute way to prescribe the exact steps in the data cleaning process because the processes will vary from dataset to dataset. But it is crucial to establish a template for your data cleaning process so you know you are doing it the right way every time. Thus, data cleaning is the process of detecting and correcting corrupt, inaccurately formatted, duplicate, or inaccurate records from a record set, table, or a database. 70% of the time, data analysts are busy cleaning and transforming the data in a usable format. So, it is the most crucial step of data analysis and modeling.
In this lecture, we install Python on Mac and we will write our first sample script. Before installing Python, you need to check whether Python is already installed or not. To verify, open your Mac terminal and type command Python 3. Hence, this message indicates that Python is not installed on your Mac machine and asking from whether you want to install. For now, click Cancel. We will download Python from browser and then we will install. Now, open your browser and go to Python official webpage or type download Python in Google search. Here, click on that yellow download button to initiate Python download to your Mac. Now, open your download folder and run the Python installer. The installer will walk you through the fundamental steps of installation. Just click the Continue button several times. Click Agree and Proceed. And now click on Install button. Provide your admin username and password and click Install Software button. And you will see installation has started. The installation process will take a couple of minutes. Wait till then. Here are the Python installed files. Here it is. Python installed successfully. Click the Close button to finish up installation. You can see the Python is appearing in the applications directory. Now, let's see how to launch Python from the terminal and write some script. First, check the present working directory using command pwd. Present working directory is admin. Type cd .. 2 times to move up to the root directory. ls command is used to show all contents of your current directory, so we can see the application folder. It means currently we are not in the root directory. Now, step into the applications directory. We are in applications directory. Now type python 3 version to check version, and here it is. Now type just Python 3 to launch Python interpreter for writing any script. Let's type 1 plus 1 and 3 greater than 5. And you can see Python is giving us results of our scripts. So let's open your browser and head to the official download page. Now proceed to download button. You can download the Python for Windows, Linux, or Mac. At the moment, we're gonna download Python for Windows. Our installer has been downloaded successfully. Launch the installer. Here it is. Our Python installer is launched. Follow the default instructions. Click on Add Python 3.8 to Path checkbox and click Next. After clicking Next button, Python installation has started. Installation process will take a couple of minutes depending on your system speed. Here it is. Our installation is complete. Click Finish and launch the Windows command prompt to check Python installation. In the command prompt, type the command Python version. If it shows the Python version, then congratulations. You have now Python installed to perform wonders. Now, type the command Python to step into the Python interactive mode. In the Python interactive mode, you can type command and get instant results. Like, I want the result of the following mathematical expressions. This is how you can use Windows command prompt to launch Python terminal. Now, it's time to launch the Python's own integrated development environment. You can launch Python IDE from Start menu. Here is the Python IDE on my screen. You can perform any calculations you want, like 12 plus 78 times 453. Hit Enter and Python will display the result. Now, I can create a variable num1 and assign it the value 56. Again, I create second variable num2 and assign it 678. So here is the result. What if we want the division of these two variables? Here is the result. Now, we will see how to create a separate script. Click on the File menu and then click New File. Now, I write the same code we wrote a moment ago in our script file. Create two variables, num1 and num2, and store any values in these. Now, print the sum, difference, multiplication, and division of these two variables. In subsequent chapters, we will explore the concepts of variables, functions, data types, and much more. Before running the script, save it by clicking on File and then Save. Now choose the path and a valid script file name and hit Save button in the bottom of the dialog window. Now, run the script by clicking on Run and then Run Module, or simply press F5 key on the keyboard. And here is the result of the script file in the main Python terminal. Okay folks, in the next videos, we will see how to install Anaconda, a super Python toolbox, shipped many marvelous tools. One of them is Jupyter Notebook that we will be using throughout the course for coding. Hi everyone, now I will show you how to install Anaconda Navigator for Python. Open your browser and type Download Anaconda in the Google search bar. Now click the first link. It will take you to the Anaconda official page. Now scroll down to this page. Here, you can see the Anaconda for Windows, Linux, and Mac. I will download Anaconda for Windows 64-bit. Our installer is downloading as the installer size is more 450 MB. That's why I have already downloaded the installer. I launched the installer. Click on Default Options and keep clicking Next button until you see the installation progress. So, the installation is completed. Now, launch the Anaconda from Start menu. Here it is. Our Anaconda is ready. Here, you can see bunch of built-in tools installed, and you can install many more. You can manage all the tools at one place, and that is Anaconda Navigator. Here, we are interested in Jupyter Notebook to write codes and perform complex coding tasks. This is the interface of Jupyter Notebook that we will investigate as we move forward. First, rename this notebook by clicking on that untitled one on the top of the notebook. Enter a relevant name and hit Rename. Now, to write sum, we write code in this cell like 34 plus 23. Now enter. When you press enter, Jupyter will create room for new line. And if you enter Shift plus Enter keys, it will execute the code in that cell. You see, we performed some mathematical computations, creating some variables and assigning them some values, and then perform some actions on those variables is quite easy in Jupyter. So, in the coming lecture, you will learn more about Jupyter Notebook. Hello everyone, now we will see how to install Python on Linux operating system, and there are many ways to do that. And easiest one is through terminal. So let's just search for terminal. Open terminal to check Python is already installed or not. Type the commands Python. No, we do not have Python. So let's just type Python 3. So yes, we do have Python installed on this system. But if you don't have one, don't worry. I am just going to guide you through the entire process how we can actually do it. So for that, we do have a command. But first, let's see some mathematical functions that we can use in Python. So type 23 plus 23 is 46, and 1 plus 45 divided by 56 into 89, and press enter. But if you don't have the environment, so we do need to install it and just see how to get it. So let's just type in sudo apt update. This is for updating the software repository. But since it is updated for mine, so I'm just typing installation command for this. Okay, so sudo apt install python 3. But I do need to check whether I do have idle installed or not. So let's just search for that and search for idle 3 is installed or not. Yes, I need to install idle 3 first. Okay, sudo apt install idle 3 and press enter. It is asking for password. Just enter the password. It is asking me for continue. Yes. Press Y and press enter. Okay, I get an error over here that is gateway timeout. Let's just fix it first. Idle tree, so not installed. Let's just try reinstalling it. So before that, sudo apt update to update software repository. Let me just zoom it for you. After updating, I'm installing idle3 again by command sudo apt install idle3 again. Press enter. Okay, so now you can see the installation has begun. Press Y to continue. So the installation of idle3 has begun. You can see the installation progress. Now we will launch it. Search idle3 again. Yes, idle3 is installed now. Click the idle3. It is installed in our system. Congratulations. Let's just type some mathematical commands again. That is 36. Create some variables and assign them values. Press enter to see the result. Now let's see to create a Python file and write some code there. Okay, so now if you want to create a Python file to create and save a script for that file, new file, and here I'm going to write my script. num1 is equal to 90 and num2 is equal to, let's say, 180. Press enter and I'm going to print num1 plus num2 bracket close. And now I need to save it. To run it, I go to File, Save. Now I need to select a path so that I can save it in my current work directory. I am just going to name the file my module, and before I save it, the extension for this is .py because this is the Python file extension. So the extension for the Python file is .py, that is why I have typed it. I'm going to save it. Let's run it. Now I'm going to run the option and then run the module. Okay, so the shortcut for this is F5. That's the result I get. But let's just open the file again and change num1 to, let's say, 190 instead of 90. And now just save it and run it again. So now you see that the result has changed. Thank you for watching this video, and I hope it helped you to how to install and set up a Python environment on your Linux system.
The object of this lesson is to get familiar with the syntax of Python. There are two methods that can be used to execute your code. Number 1, interactive mode. Number 2, script mode. Interactive mode is a kind of glorified calculator to get your results as soon as you enter the statement or expression. It is helpful if the script is extremely short and you want immediate results. On the other hand, if you need to write a long piece of code or your Python script spans over multiple files, then script mode is the way to go in such cases. In script mode, you write your code in a text file, then save it with a .py extension, which stands for Python. You can use any text editor for writing Python script. Some of the great editors are Sublime, Atom, Notepad++, etc. If you are in the standard Python shell, you can click File, then choose New to write a script after writing your code. You can run it by clicking Run or press F5 or execute script file from Jupyter or Spider as well. Python variables are space in memory
of the computer to store some kind of numeric or text value. So you need to create that space in the computer memory before storing and retrieving a value from a variable. In Python, a variable is declared by a valid name, and after using equal sign, you can assign any value to it. You can declare multiple variables in a single statement and assign values to each of them separated by a comma. Don't worry, we're here to show it all to you. Instructions that a Python interpreter can execute are called statements. For example, x is equal to 1 is an assignment statement, which can be written in a single line. Return statement, if statement, for statement, while statement, etc. are other kinds of statements, which will be discussed later on. An expression is a combination of values, variables, operators, and calls to function. The interpreter evaluates the expression and displays the result if you print it. Most of the programming languages use braces to define a block of code. Python, however, uses indentation that makes the code more readable. Generally, 4 white spaces or a tab key is used for indentation. The enforcement of indentation in Python makes the code look neat and clean. In this lesson, you learned the theoretical concept of syntax being used in Python. In the upcoming sessions, you will learn about variables and how to code them in Python. Hi, let's have a detailed look at variables and identifiers. So what is a variable? A variable is a reserved location in a computer memory to store your values. We can store different data types. You can create variables to store numeric, text, or logical value. Unlike other programming languages, Python automatically reserves the memory space for each type of variable you create. Here is the diagrammatic explanation of memory and variable storage. N1, N2, and sum are the names of the variables having values 345, 56.3, and 401.3 respectively. And what is an identifier? An identifier is the name given to a variable or other entities in Python, such as functions, modules, classes, and so on. Identifier is a valid name that is given to a variable, function, or a class. The variable has other properties, such as values, types, and scope. In Python, there are certain rules to create names of identifiers that we will discuss next. Firstly, remember Python is a case sensitive, like two names with different cases are considered two different identifiers. For example, variable x and variable capital X are not the same. No special symbols are allowed as identifier names except underscore and digits. But identifier name cannot start with digits either. Rest. Your identifier can start with letters and underscores followed by underscores digits or letters. Reserved words such as if, for, return are not allowed as identifiers. Developers use best practices for naming variables, functions, and classes like create identifier with upper, lower, or first letter of the identifier as upper if the identifier has a single word. Use camel case if identifier is of 2 or more words. In camel case, the first letter of the first word is lowercase, and first letter of the second or third word is capitalized. Here is a list of some valid and invalid identifiers, and they will be explored in lab work during the whole course. So for now, you have developed the basic understanding of the variable. Now open Jupyter Notebook and do some action. Okay, I have launched my Jupyter Notebook and we are in interactive mode. Good thing about the Jupyter, it is in interactive and script mode at the same time. Let's learn something simple first, that is declaring a variable with a valid name. And along the way, I will tell you about data types as well. Declare a variable called age and assign a value 23 to it using equals to operator. Now, to print it, simply type age in the next line and press the run button on the top of the screen. You will get output 23. Instead of pressing the run button every time, you can simply press Shift plus Enter keys together to execute your code. Now, declare another variable name which holds value Sarah. To assign string values, use quotation you will learn about in the next lecture. Now, print this value using Shift plus Enter key. Let's run it and see the result. The Python interpreter returns name is not defined in the output cell. Recall, Python is a case-sensitive language, which means name and name with a capital N are two different variables. Okay, what if I use an invalid name unknowingly or by mistake in Python? Here, I am typing 123 name as variable and passing it some value. Let us print this variable as well. The Python interpreter will throw an error of invalid syntax as soon as I execute my code. So, I would like to run or reiterate my point. Follow the naming rules as I discussed in the earlier slides. Come on, try some more examples of variable names. Type underscore number is equal to 5 and print it. It shows the result with no error. You can also give descriptive names to variables, such as movie names. Type a movie, space name, and pass value to it. Next, print it. You will notice a syntax error in the result, as space isn't allowed between two words of a variable. Now, use underscore in the middle of this variable and get it. Print it as a valid name and result is displayed without an error. You cannot use reserved words as variable names. This is because they are used by Python to perform some operations. But if you change the case of a letter, you can use them. But I will not recommend such a practice, as it will lead to confusion. If is a reserved word when used in lowercase, so it can't be redefined by the user. But after changing it to all uppercase, it is used successfully, as you see.
In Python, we have 4 different data types. Let me ask you a question. What is your name? What is your age? Do you have friends? What are their names? Imagine your answer is, my name is Sarah and I am 20 years old. Yes, I have 3 friends, Shirley, Thomas, and Brian. In your answers, you can easily figure out that every answer has different types of data. Sarah is a string, 20 is an integer, yes is a boolean. Name of friends are sequence data type. Now, let's open Jupyter Notebook and look at an example code.
Declare a variable called age and assign a value 25 to it, as 25 is a numeric value. This variable is of integer data type. You can check it also using the method type. Pass the variable name age to it and run the code. It says class int, that is, the variable age belongs to the integer data type. Now declare another variable student which holds value Sarah. Since it is a string, you have enclosed the value in single or double quotes. That is the identification of string value. Print a value using function print. The print is a built-in Python function to display variables or literals. Now, execute your code using Shift plus Enter key. These results are familiar to you. Now, I am declaring another variable and passing it value 5. Now, add this number with itself. Run your code. You can see that instead of adding 5 with 5 and giving 10 as output, it is repeating the variable, or you can say concatenating the two numbers, since 5 is not a numeric value but a string. Now you can get the idea of data types as well. Type salary as variable name and pass 1523.56 to it. This is an example of floating point data, as it carries decimal points in number value. Now print the value. We can use method type to know variable and data type. Here, instead of printing the value of salary, I am using a type method to show you how it works. The output screen shows float in the result. Let's learn how to declare a Boolean value. Boolean can have only true or false as values. Coming to the last point of the session, variable names can be reused again with same or different data types. Earlier name has value Sarah, now I'm reassigning value to Martin. Now, if I print this variable, it will show me the latest value. Python is a super language. It decides the type of variable according to the type of value assigned to it. In the next tutorial, you will learn how to add comments to your code. Till then, happy coding!
Comments are lines of text that, like remarks or annotations, we use them to provide some contextual information. Python ignores and never executes the commented lines. In Python, we use the hash symbol to write a single line comment. Comments are very important while writing a program. They tell you what is going on in the source code, and you do not have a hard time figuring it out. We can have multi-line comments that can extend up to multiple lines. One way of using them is to use the hash symbol at the beginning of each line. And another way of doing this is to use triple quotes. Let's have a quick recap of this module. In this module, you learned the basics of Python and its syntax. You learned variables and identifiers, how to declare and use them, what are the naming conventions, and how to insert a single line or multi-line comment in Python. Now it's your time to practice all this stuff in your Jupyter Notebook or Python shell. See you in the next module.
Open your Jupyter Notebook. Comments are a very important part of your code and used to explain it. In Python, comments start with a hash symbol. Here, I am typing a sentence. This is a single line comment. Now, type a sentence. Welcome to Python tutorial in the next line inside print method. Run your code. The Python interpreter will ignore them while executing code. As you see here, only the sentence provided in the print method is shown in the output cell. Comments can be used not only to explain code, but to stop code from executing. Copy and paste the above cell and comment out the print method. Now, and write a new method print with a new sentence to comment out some lines of your code is particularly helpful while debugging, that is error finding. You can also add multi-line comments in your code either by adding hash symbol at the beginning of your each sentence or by using 3 single or double quotes. Both are correct ways. Let me show you an example of it. It is a multi-line comment as it spans over multiple lines. Next, I am typing a print statement which says, "Hello world." See the result? The lines enclosed in 3 double quotes are ignored by the Python interpreter. You can repeat the same process with 3 single quotes as well. In this lab, you learned how to insert single or multi-line comments in Python. Do practice them and enjoy learning Python. We can encounter various errors during program execution, such as syntax errors, indentation errors, out-of-memory errors, etc. Syntax errors, often called as parsing errors, they are predominantly caused when the parser detects a syntactic issue in the code. Let's take an example to understand it. Say A equals to 5 and B equals to 2. Here, I want to add two numbers together, and let's say I miss the addition operator here deliberately and store the result in C. Now print the variable C. Run the code and see the result. See, it says invalid syntax, as there is no operator between two numbers. So let me add the operator, next run the code, and see the result. It gives 7. Even if you missed the closing bracket, you can run it into syntax error, saying unexpected EOF while parsing. So there are different types of syntax errors. Indentation error is similar in spirit to the syntax error and falls under it. However, they are specific to the only indentation-related issues in the script. So let's take a quick example to understand an indentation error. For example, let me run a for loop. For I in range 1 to 10, then if I type loop body unindented, it gives an indentation error. Run the code and it shows a syntax error as I missed the mandatory indentation. After the for loop, Python interpreter is expecting an indented block of loop body. Let me indent it, run the code, and see the error is gone. We can also run into memory errors that are mostly dependent on your system's RAM. It can be caused due to various reasons, such as using 32-bit Python architecture and having a maximum memory allocation between 2 GB to 4 GB, which is very low. It may also be caused if you are loading a very large data file, or running a machine learning or deep learning model, etc. So, this is a very brief introduction of syntax errors. Moving on to exceptions. Even if the syntax of a statement or expression is correct, it may still cause an error when executed. Python exceptions are errors that are detected during execution and are not unconditionally fatal. If the script explicitly doesn't handle the exception, the program will be forced to terminate abruptly. So let me show you an example. Say we have two variables, A and B, A having numeric value and B holding string value. Now add them together and save value in another variable, C, and print it. As numbers and strings cannot be concatenated together using plus operator, we run into exception error. It raises a type error as string and operator cannot be added together using plus operator. There are specific features in Python to deal with exceptions and exception logic. Use try except block to catch exceptions. You should specify as precise an exception as you can. Let me show you how to do it. Using the example discussed earlier, this one an integer and a string are added, which results in a type error. But this time, in a try block, indent the code as it requires indentation. Add an except block and pass a print statement here. Strings and numbers cannot be concatenated. Run the code, and instead of nasty exception that we saw earlier, it displays strings and numbers that cannot be concatenated. That is, the user-defined message passed in the print statement of the except block has been printed. So what happened? Basically, the code in the try block is parsed and evaluated by the interpreter. And when it found an exception, the control falls into the except block, and instead of disgraceful program termination, the code in the except block is executed. We can also call built-in exceptions here and alias them. Here, we earlier encountered the type error. Now make your except block specific to type error. So this is specific to this exception only. Type error exception is raised when two different or unrelated types of operands or objects are combined. Now this except block is specific to the type error only. So if we have another error like maybe an unclosed bracket, it is not handled by this except block. You can also alias them. Here I am calling type error as E and calling E in the print statement. Now run the code and the changes in result, the value of E is also printed along with my statement. Okay, now let's see another example. Suppose a number is divided by 0, as a number cannot be divided by 0. The interpreter will raise an exception error. Now I have a built-in code snippet for you. Here I am dividing 5 by 0, and we already know that it will result in an error. To handle this problem in the exception block, I'm calling the built-in exception zero division error aliased as E, where E is the exception object. In the print statement, I pass the custom message along with the E. Run the code and it says exception block gotta divide by 0. The exception was division by 0, which is the default message. However, if you pass a non-zero number, say 1, then try block is executed with no errors. Write print statement to verify. It says 5 as 5 divided by 1 equals 5. We will discuss some more exception errors and different variations in the upcoming video. What is a name error? If I try to use a variable or function name before defining it or because of a typo mistake. Here is a code snippet. Instead of calling variable name, I called company in print statement. It will surely result in the name error exception. Let me run the code and see the result. It says name error and company is not defined. Let me pass this particular piece of code and try an except block. So instead of throwing nasty error, it prints the message that I passed an exception block. We also have an else block too. In the try clause, all statements are executed until an exception is encountered. Except is used to catch and handle the exceptions that are encountered in the try clause. Else lets you code sections that should run only when no exceptions are encountered in the try clause. Let me add an else block. Run the code and see if an exception is raised. Then it is not executed, but if I call variable name, then else block executes too. Moving to value error. Value error in Python means that this is a problem with the content of the object you try to assign the value to. Imagine you want a user to enter a number via input. You want to ensure that the input is a number. You can use try or except for this. Here, I already wrote a code script for you which takes user input, converts it into integer, and if the number happens to be non-numeric, an exception will be raised. In the except block, I passed a message in print statement saying this is not a number. Run the code, it asks for an input. Suppose I enter A here. The exception is raised, this is not a number. Next, we have key error. Suppose we have a dictionary which has key value pairs and you want to access a key that is not present in it. Then a key error will be raised when you try to get a value from a dictionary for a key that doesn't exist. Let me show you an example. Here we have a dictionary called data with two key value pairs. And you want to access a key that is not present in the dictionary. Then a key error will be raised. For example, I'm trying to access key 3, which is not present in my dictionary. In the accept block, I passed a custom message. Run the code. If I access 3, it returns key not found. But if I pass 2 in the print statement, the value of 2 is printed without any error. Moving to user-defined exceptions. Our code can encounter a condition that it doesn't know how to handle, such as an incorrect parameter. This is a code snippet. If x is greater than 9, then this keyword helps to raise an exception. As it is a user-defined exception, depending on the value, it cannot be handled in an except block. Let me run the code for you. It says x should not exceed 9 and value of x was 10. If I alter the value of x, say x equals to 5, and now run the code, then no exception is raised. Last but not the least, we have finally block. Use the same code of try catch we did earlier and add a finally block to it. Pass a print statement which states finally block. It runs even if your code encounters an exception. Let me change the name of the variable, as we know it will raise an exception. Let me change and answer the company my mistake. Run the code and an exception is raised, but the finally block is executed. If I pass name and print statement, then both try and finally blocks are executed. So either way, the code in the finally block is executed, which says cleaning up irrespective of any exceptions. Let me show you another example. This code snippet can be used to read the contents of a file. If a file is not present, then except block will be executed. And the finally block is run in either case. Run the code even if the exception error is encountered, but the finally block is executed as well. In this block, you can close resources that you have used or clean up work. Summing up all together now, I am adding else here too. Using a simple example and pass else block here. Now, if an exception is raised, then only except and finally blocks are executed. However, if the exception is not raised, then try, else, and finally blocks are executed. This is how exception handling can be done in Python. It is one of the prime factors in making your code production ready and should be part of any project.
Welcome to module number 7, working with data structures. In the previous lessons, we discussed variables, their types, and how to manipulate them and perform operations on them. Let's have a bit more depth into the variable. Think about it. A variable can store one piece of information at a time, only, and can be modified. What if you need to store a long list of information which does or does not change over the period of time? In Python, we have 4 basic inbuilt data structures: list, tuple, dictionary, and sets. Every data structure stores data differently, and different operations can be performed on them. I will be discussing each of them separately in the upcoming sessions.
For any type of object, from number and string to other lists, lists in Python are indexed and we can access lists just like a string that we have done in the earlier session. And so they are simple to use and can be of different length. They can grow and shrink automatically. In reality, the list data structure is just like an array in other programming languages. List is an ordered and mutable collection of data. That means it can be changed once defined. In Python, lists are written within square brackets. For example, here's a variable called veggies. It is basically a list, as you can see that carrot, potato, and cucumber are enclosed in square brackets. You can print your list using the print function. Give parameter veggies as an input to the print function, and the output you will see in will be carrot, potato, and cucumber. Each of the item can be accessed using index number. For example, if you want to access carrot, you can simply use 0 in square brackets after typing veggies in print function, and you will get the result carrot. We can perform multiple operations over list. If you want to repeat each element of a list, simply multiply your list variable with that number. That is, if you want to repeat the list elements twice, then multiply your list variable by 2. To repeat them twice, multiply it by 3. Now coming to list operations. Multiple operations can be performed over lists. We have the concatenation operator in which you can concatenate lists together. We have L1 having element 1, 2, 3, 4, and we have another list with elements 5, 6, 7, 8. If perform concatenation using plus symbol, then the output is 1, 2, 3, 4, 5, 6, 7, 8. First four elements are from list L1 and the last four elements are from list L2. You can concatenate any number of these lists together. You can also find the presence of an element in a list using membership. Let me recall you. We have multiple operators out of which there's a membership operator in and not in. Here the membership operator will try to find whether 2 belongs to the list LST. If it is in the list, then it will print true, otherwise it will print false. By this time, you are familiar with the for loop. Here the for loop is used to iterate over each element of the list, any list, and print its element one by one. Also, we have many methods associated with the list. For example, to find the length of the list, we use the len method. To find minimum and maximum elements of a list, use min and max functions. You can also sort your list with a simple function and add elements in your list using the append function, as I told you that lists are changeable. To delete elements of a list, use remove method. And to delete a list, use the del method. As discussed in the slides, let me create a list of veggies, put some values in a square bracket, say carrot, potato, onions, turnip, and broccoli. Now, if I print this variable veggies, the output cell will show me the list of veggies. As lists are indexed collections, you can access individual elements of the list using an index number in a square bracket. As we know, there are two ways of indexing, positive and negative. In positive indexing, each element has an index which increases from left to right. To access the first element, use index 0. Type the name of your list, veggies, and pass the index number 0 in the square brackets. It returns carrot, the very first member of the list. Potato is associated with 1, turnip with 2, onion with 3, and broccoli with 4. If I say veggies with index 4, it returns broccoli. Notice that even my list has 5 elements. The indices go from 0 to 4. So, if I ever use the index 5, I will get an error because index 5 does not exist in the list. Now, in negative indexing, the last element of the list has an index of -1, and the second last element has an index of -2, and so on. So let me show you an example to access the last element of the list. Provide -1 in indexing, and it will return the last item. As you see, it returns last element, that is broccoli, from the list. You can access a range from a list by specifying where to start and where to end in a square bracket using colon. Type veggies, square bracket, open 2, colon 4, and close the bracket. Run it, it returns turnip, present at index 2, and onions located at index 3. But the value at index 4 is not returned. The range works this way that the ending element you specify will be excluded from the list. You can also leave the starting index and pass ending index in brackets. In this case, 0 will be the default index. So, if I run the code, I get a list from index 0 till index 4, but again, index 4 is excluded. Now, I'm demonstrating an example of specifying range using a negative index. Type veggies -2, colon -1. This example returns one item from index -2. Item at index -1 is excluded. It returns onion only as onion is at index -2, which is my starting range position. An element at index -1, broccoli, is excluded, as -1 is my ending value in the range. So you learned how to create a list, then assign it to a variable name or an identifier, and you learned how to access elements using indexing. Remember, the order of the objects in your list matters. There are more operations which can be performed on lists. You can perform different operations on lists, such as iteration, concatenation, repetition, insertion, deletion, etc. First, let me tell you about concatenation. I am going to concatenate two lists. First, I am going to define another list of fruits and pass some values in square brackets. Now, I am going to use add operator to concatenate veggies and fruits into a new list, Print this list using print function. You see a new list having items from veggies and fruits list. Notice that your original list, that is veggies and fruits, are intact. That is, there is no change in them. Or use the extend method to append a list, say fruit, into another without creating a new list. Type veggies.extend fruits. This particular line will add items of fruits into veggies. Now print veggies either by using print function or simply by using name of list. You can see a list here, which is the combination of items of list, fruits, and veggies. This is how we do concatenation in Python. Let me do some magic for you. How to repeat each list element for n number of times. Let me declare a simple list of numbers L1, type some numbers here. Now, multiply this list by 2. See, each element is repeated twice in the list. You can use any other number here and see the difference in the output cell. This is how we perform concatenation and repetition over list in Python. Here, I am modifying the value at index 0 with capsicum. Now print the list and check the result to see the modified value. As you can see now, we have capsicum at index 0 rather than carrot, as the value is modified in the original list. You can not only modify a list, but can also add new values in it using function append. Type veggies.append and pass beetroot. Now print the list here. Output cell shows the new value at the end of the list. You can also find the length of the list using function len, type len, and pass the name of the list to it as an input. The output cell returns 9 as we have a total of 9 elements in the list. You can also insert an item at a particular index using the insert function. The insert function works with two input parameters. The first parameter asks for the index where you want to add an item. Say, I want to add an item at index position 2. And in the next parameter, pass an item value or list of values. Let me run this code for you. See, cabbage is inserted at third position, that is, at index 2. To remove an item from the list, pass its value to remove function. Type veggies.remove and pass any value that you want to remove. Say, I want to remove apple from the list. See, the output apple is now deleted from the list. To remove an item from a location, use del method followed by list name with index. For example, I wish to remove potato from the list. Type del veggies and pass the desired index number to it. Run the code. Now the element potato is deleted from the list. There is another method, pop. It always removes the last element from the list. Type veggies.pop. It requires 0 argument. See, beetroot is removed from the last of the list. You can copy one list into another. Let me declare an empty list, my list. Print it. The output cell will show an empty list. Assign veggies.copy to it and print my list. It now carries all values of veggies in it. There is a built-in list function to sort elements alphabetically. Let me apply this method on my list. Type mylist.sort. Now run it. As you can see, the list is now arranged alphabetically. You can also find minimum and maximum value from a list. Here, we have a list of string, so let me apply max on it. It returns turnip, as turnip is the one that is at the bottom of the alphabetically arranged list. Next, apply minimum. It returns broccoli as it is at the start of the sorted list. You can also apply these methods on a numbered list as well. For example, we already declared a number list L1. Let me find maximum value of list L1. However, you can do some more experiments with it and try some more functions with it. Moving to our second data structure, tuple. Tuple is a collection which is ordered that its sequence is maintained and immutable, unlike list. A tuple is a comma-separated list of values, usually enclosed in parentheses, but parentheses is not mandatory to define it. Now, I am going to declare two tuples. Let me define a sequence of numbers from 1 to 5 in a parenthesis. And we have TPL2 with comma-separated values. Both of them are tuples. Print each of them in print function. See, both of them are represented as tuples in the output cell. For confirmation, you can use the type method. Type TPL1. It returns tuple. Type TPL2. It is also a tuple. But usually, when we define a tuple in Python, we use parentheses. Tuple can also be created with mixed data types. Let me show you one. TPL3 is equal to cat 12 true 36.56. Now, let me print it. This is also a valid tuple, having values cat 12 true and 36.56. You can create a tuple with a single element. However, it is necessary to have a trailing comma in parentheses. Suppose I type T1 and assign only a single character A without a trailing comma. It will not be considered a tuple, but a string. Print this tuple and the output shows A with no parentheses. To confirm it, let me print the type of object T1. As you can see, the data type of T1 is str, that is a string, not a tuple. Now, adding comma at the end and executing the code. Now, T1 is a tuple. Elements can be accessed using indices, just like lists. Type tpl1 and in the square bracket pass index 2. It returns 3. As we have 3 at index number 2 in our tuple tpl1. Type tpl-1, it returns last element. To access a range of values, specify it similar to what you have done in the list. Type tpl1 and, in square brackets, provide a range, say 2, 5. Run the code. It returns 3, 4, and 5. The element 5 at index 4 is returned in the result along with other two values, but there is no element at index 5. Remember, range excludes the index specified in the ending position of the range. You cannot modify a tuple once it is created. However, you can delete the entire tuple using del method. Type del tpl1. This deletes the tuple tpl1. Now, if you try to print tpl1 in the next cell, it will give you a syntax error. tpl1 is not defined as it is not present in the memory anymore. Let me define a tuple of colors having values red, yellow, green, and black. Print the tuple. Now, I would like to iterate each element using for loop. Using the syntax of for loop to iterate the sequence, type for x in colors. Print your looping variable x. In the output cell, you can see the values printed one after the other. Tuples also allow repetition operation. Here, I am multiplying my tuple colors with 3. Now each element will appear thrice in the tuple, but this operation results in a new tuple rather than modifying the original tuple. To check this, print tuple colors in the next cell. See, there is no change in the original tuple. You can also use membership operator in or not in to find the existence of an element in a tuple. Here, I am taking user input to find the existence of a color provided by the user in my tuple. Type enter the name of your color, employing if-else to do the job. Type if user in colors, then print it if it is found in colors, otherwise print it is not found in tuple. Here I typed red. It says red is found in colors. You can try different input values and see how it works. Now I'm going to find the length of the tuple using len method. Print len colors. The output shows the result 4 as there are 4 elements in the tuple. As tuples are immutable, you cannot add or append value in it. Let us try it by assigning new value white at index 0. Print tuple colors. The interpreter will throw an error that object does not support item assignment. You cannot remove items from a tuple but delete the whole tuple as I told you earlier. Concatenation can also be performed. Use plus operator to concatenate two tuples, which results in a new tuple. Here, I'm defining a new tuple, colors2, and now I am concatenating colors and color2. In the output cell, you will see a tuple having elements from both tuples. Remember, this is a new tuple, and original tuple colors and color2 remain intact. Tuple has two methods, count and index. Next, we have an index method. Index method is used to access an item at a particular index number. Say, I want to find the index of value. Now try with 2. It returns 1 as element 2 is at index position 1. If we have multiple occurrences of the same element, then returns the first index position of the element, which is 1 in our case. Now exploring count method of tuple. Finding the count or frequency of an element, say 2 in the tuple. Here it returns 2 as number 2 appears twice in my tuple. Similarly, you can try it with other values. You can also unpack tuple elements using multiple assignments. Define a new tuple TPL underscore new. Now I am going to unpack the values of tuple. Here I am using 3 variables to unpack my tuple TPL underscore new. Next, print values of your variables. See, X holds first element, Y holds second element, and Z holds the third element of the tuple. Notice, number of variables should be equal to number of elements inside a tuple. So in this lab, you learned about tuples, operations that can perform over it, and how to unpack values of tuples. Hope you find this lesson interesting. See you in the next lecture with a new topic. Once you define a tuple, its value cannot be modified later. Tuples are comma-separated values in a round bracket. You cannot remove items from it. However, you can delete the entire tuple using the keyword del. Duplicate members are allowed in a tuple. Tuple has 2 built-in methods, count and index. I will demonstrate both later in the lab. Moving on to the accessing methods of a tuple. To declare a tuple, use a variable, say TPL, here with values 1, 2, 3, 4, 5, enclosed in a round bracket, which is the identity of a tuple. And next we print it out using the print method. If you run this code in Python environment, you get output 1, 2, 3, 4, 5. To access individual elements from tuple, you can write TPL in a square bracket past the index that you want to access. To access a range of values, you can provide that range using indexing in square bracket. Just provide starting and ending index separated by a colon. To delete a tuple, you can use the method del and then provide your tuple name after space. Just like this, you can perform multiple operations on a tuple. You can repeat the elements in a tuple. You can iterate through tuple using loop, You can also find an element in a tuple using membership operator and tuple length. Welcome back. In this lesson, you will explore a new data type in Python, and that is dictionary. Dictionary is a collection which is unordered. The values of a dictionary can be any Python data type. So dictionaries are unordered key value pairs. Changeable, that its values can be modified later. Dictionary data structures store values in the key value pair and they are written within curly brackets. Instead of indexing, key is used to access the value, just like as you search the meaning of a word by searching the word first. As dictionaries are referenced by key, they have very fast lookups. As they are primarily used for referencing items by key, they are not sorted. Dictionary does not support duplicate keys. However, more than one value can correspond to a single key using a list. Here is the syntax of declaring a dictionary. The dict variable key value pair separated by a colon enclosed in a curly bracket. Dictionary data structure is not indexed by a number. Instead, you can have an index of words, and for each word, you have a corresponding definition or a value. As they are mutable, you can add, remove, and modify values in a dictionary. You can access individual elements using indexing technique or can iterate through each element using different methods. If you wish to print just keys, you can iterate through dict.key method. For values, only use dict.value method. To access each item one by one with both key and value, use method dict.item. You can take user input to store values against predefined keys of a dictionary. I will teach you the coding example present here one by one. Here is one more example of storing and printing data for your practice. In this lesson, you learned about how to create, modify, and delete a dictionary and perform operations over it. The key to success is practice, so enjoy coding. A dictionary is an example of a key value store, also known as mapping in Python. It can be initiated in many ways. For example, you can create an empty dictionary or provide a dictionary with key value pairs. Let me show you both ways to you. Here, I'm typing D and assigning an empty dictionary to it. The curly braces is a representation of the dictionary. In the next line, I'm calling type function. Now, run the code. The output cell shows empty dictionary with type representing dictionary. Next, I'm going to create a dictionary with key value pairs. Let me call it mobile with keys, brand, model, and price. Now, I'm going to assign key value pairs to it. The value assigned to brand is Samsung. See, the key and value are separated with a colon. To another key value pair, type model. As both my keys and values are of string data type, so I have enclosed it in double quotes. You can use single quotes as well. Let me show you an example of it. Type mobile and pass any key in square brackets that you wish to access. See brand. Samsung is mapped to brand. Similarly, you can also access the model and price. You can assign multiple values in a list to the key. Price is a single key but holding two values using list. See the square brackets in which numbers are enclosed? Let's access the key price using the get method. Elements can be accessed using get method and dictionary. Let me call the get method. The get method inputs key, say price, and returns its value in the output. The output shows the list of price 550 that you can access elements of the dictionary using square brackets as well as the get method. Iterating over dictionary is pretty simple using for loop. Here, I am using a for loop and printing both keys and values of my dictionary. Here, X is used to print keys and square brackets are used to access the value of a key. The same thing can be done by using the items function. This function retrieves keys and values simultaneously from a dictionary. Here, I am using two variables in a for loop, one for key and the other for value. See the output cell? You can print either keys or values depending on the scenario. Values method can be used to iterate over only the values as expected. Then we have keys method, which only returns keys of a dictionary. Both functions are already implemented here. You just need to have a look at it. To check the existence of a key or value, use membership operator in, along with calling the appropriate dictionary method. Here, the program searches for brand in the key list of dictionary. If it is there, then it prints yes. Otherwise, print a sentence, no, model is not listed in the keys of mobile dictionary. To find the length of a dictionary, use len method as used with the other data types. Here the length of the dictionary is 3, as we have 3 key value pairs. You can take user input here as well as discussed in the last lecture. The result shows an add key value pair. You can remove item from it by passing key to pop method. Here, I'm removing model from dictionary using pop method. See the output cell? To remove last inserted item, we have a method called popItem. To delete a whole dictionary, use del method. Press enter and a mobile dictionary is no longer in the memory. But if you want to clear a dictionary without removing its reference in the memory, use clear method instead of del method, as it removes the reference of the object from the memory too. You can copy one dictionary into another using built-in copy method. A lot of methods are the same for these advanced data types. You can play with them. Now, I am creating a dictionary with keys, company name, age, and net worth with 0 and empty values. Print the dictionary. I am going to take user inputs to fill the values in my dictionary. Access each key and pass value to it using input function. Type company and then assign value using input function. Do the same for the remaining 2 keys as well. Now run the code and pass values one by one. For company, I'm entering Google. For age, enter 22. For net worth, enter $280 billion. Now, print your dictionary to see the effect. All user inputs should now be a part of the dictionary user_dict. In the last lecture, you learned how to declare a dictionary in Python. Now you will learn how to implement a set and other important Python data structure. Set is an unordered collection of items, which means the items will appear in a random order. Unlike a dictionary, set does not allow duplicate values. The values, once defined in a set, cannot be changed. However, you can add or delete values from it. Elements in a set cannot be accessed using an index, but can be printed together or traversed through a loop. Only one type of data can be punched into a set. You will see this in the lab. To declare a set, use curly brackets. Let us declare a set. You can add items to set using add function, or if you want to add multiple items, pass values in an update method. To remove elements, you have various methods. Each of them serves a unique purpose. I will show you using some examples once we get our hands dirty with the code for the set. These are the few set operations. Python's set class represents the mathematical notion of a set. Here you can perform set operations like union, intersection, and difference operation over it. This slide is demonstrating an example of union operation between two sets, names 1 and names 2. To perform a union operation, use pipe symbol or union method. The result will be a set containing values from both sets without any duplicates. This slide is demonstrating an example of intersection operation between two sets, names 1 and names 2. To perform intersection operation, use ampersand symbol or intersection method. The result will be a set containing values common in both sets. Here in difference operation, you can find the values containing the difference between two sets. To perform difference operation, use minus symbol or difference method. Let me show you intersection and difference operation over sets by demonstrating a simple example. So this is it for set and set operations. Hopefully the ideas and concepts are clear to you. Here, I'm declaring a set called languages and assigning different values to it in curly braces. In sets, you cannot be sure in which order the items will appear. As sets are unordered, we cannot access items using indices like we do in lists, but we can traverse it using a loop. By this time, you are now comfortable with using for loop to iterate through sequences. Type for items in languages. Next, print the items. The output cell shows items in a set one by one. Moving to the operations that can be performed on a set, such as add, update, remove, pop, etc. Remember, once a set is created, you cannot change its items, but you can add new items by using add and update methods. That is, set values are immutable, but set itself is mutable. The add method adds a given element to a set. If the set is already present, it doesn't add any element, as duplicates are not allowed in a set. Here, I'm adding Android as a new element using add method. Now, print languages, run the code to see the result. Android is now part of set languages. You can also update a set with any iterable. Let me pass a list of values. Type languages.update and now pass a list of values as arguments. Print languages now. As you can see, Go and Java are now added to the set. If you pass a dictionary as an iterable, only keys are stored. Languages.update and pass a dictionary to it. Now, print the set languages and see the new values are added to the set. Notice only the keys are stored. To find length of a set, use len method, as we did in the earlier lectures. It returns 9 as mh set consists of 9 elements. Here, I am using the membership operator to find the existence of an item. If Go in languages, print element, found, and set. Let us do something useful with it. If an element found, delete it from the set using remove method. Type languages.remove and pass the value where I'm passing Go. Print the set. As you can see in the result, call element Go is deleted from the set of languages. Python offers another method to remove an item, and that is discard. Let me try this for you. Type languages.discard. Now, print the set to see the changes. As you can see, the element is no more part of the set. The difference between remove and discard is that if an item is not present, discard method will not raise an error, whereas remove method will raise an error. To make my point clear, let me remove A again using the remove method. It raises an error. However, if I use discard, no error will be raised. The del method will delete the set completely, and clear removes all elements from it as seen in the earlier lectures. Here, I'm going to clear the elements of the set languages. Type languages.clear. Notice all elements are removed from the set. If you want to remove memory references, then use del languages. Sets can be indexed or sliced. However, Python provides a whole host of operations on set objects that generally mimic the operations that are defined for mathematical sets. Let me give you an example of set operations here. Declare two sets. Name one with some values, say Pakistan, US, and Australia. And names two with UK, UAE, US, and China. Now I'm going to perform union over them. Union can be performed in two ways, either by using pipe operator or by using union methods. I will be discussing both of them here. Type names1 dot union and pass names2 as an argument. See, both the sets are merged together. See, US has only appeared once in the result, as sets elements are unique. Notice this method returns a new set and both the original sets are in the original states. Now, I'm going to perform the union operation on the same sets, but this time using the pipe operator. Type names1 and names2 along with the pipe operator. See, you get the same result. Both behave identically, but there is a subtle difference between them. When you use the pipe operator, both operands must be a set. The union method, on the other hand, will take any iterable as an argument. First, it converts the iterable to a set and then performs the union. Let me show you an example. Type x1 is equal to 1, 2, and 3. Now, I'm going to perform union operation with set x1 with the tuple having values 4 and 5. Run the code, it throws an error. Unsupported operand type or types for union. Here, I tried to merge set and tuple together using union operator. However, the same thing can be performed successfully using the union method. Type x1.union and pass the tuple to it. Run the code and see no error occurred, and both tuple and set are merged together. Union method first converts the tuple into a list and later performs union operation. Moving on to intersection and set difference. Intersection returns common elements from two or more sets. Type names1 dot intersection and provide names2 as an argument to it. Now run the code. See, the output cell displays US as it is the only common element present in both sets. The last set operation, difference. It returns a set containing the difference between two or more sets. Here, I'm finding the difference between sets name1 and names2. In the print function, type names1 dot difference names2. The output cell shows Pakistan and Australia and result, as both these countries are not a part of set 2, but they are a part of the set 1. Now do the same operation in reverse order. Copy and paste the cell and add the values. It returns UK, China, as they are not present in names 1, but they are present in names 2. Observe the difference between two results and learn this operation. So, this is it for set and set operations. If you have been part of the data science or any data industry, you would know the challenge of working with different data types and formats. Thus, it is mandatory to be aware of different file formats, common challenges in handling them, and the best efficient ways to handle this data in real life. A file is a standard way in which information is stored. It shows how the information is organized. Popular formats are comma-separated values, Excel sheets, text documents, JavaScript object notation, and many more. First, we have comma-separated values, CSV file format that stores tabular data in plain text. Each line in CSV file represents an observation, or commonly called a record. Each record may contain one or more fields which are separated by a comma. Fields in a row are separated commonly by commas, but pipe, semicolon, etc. can also be used. CSV is the simplest data format that can be viewed even in a simple text editor such as Windows Notepad. They're better at organizing large amounts of data. It is used in a bunch of domains, for example, data analysis, banking, and web. A more practical example of this would be an e-commerce business that buys customer data from a social media website. The online network would likely send the consumer information to your database in CSV format, making it quick and easy to exchange the data. This is how a CSV file looks. That data in columns is separated by a comma. Similarly, in Excel sheets, data is organized under the cells and columns in a sheet. Data is entered into those cells. Each Excel file may contain one or more sheets, so a workbook can contain multiple sheets. This is how a blank Excel sheet looks. JavaScript Object Notation, JSON, is a text-based open standard designed for exchanging the data over the web, as it is very lightweighted. JSON format is used for transmitting structured data over the web. The JSON file format can be easily read in any programming language because it is language-independent data format. Web services and APIs use JSON format to provide public data. Data in the JSON format can easily be converted to CSV, XML, spreadsheet, or CSV format. It is basically a collection of key value pairs. Let's have a look at it. In this example, name, age, city, and company are keys, and Michael, 31, Pakistan, and skill curb are their corresponding values. Multiple free online JSON converters available on the internet that can be used to convert .cs, .xml, or other formats of data into JSON format. In the previous lecture, we saw how to import data from public sources. Now we'll see how to import data from social networks. There are many social websites such as Facebook, Twitter, Instagram, LinkedIn, etc., from where you can import data for analysis. Let's concentrate on Facebook and Twitter here as an example. The questions are how to import data from Facebook and Twitter, and what analysis can be performed on it. We can analyze a particular hashtag trend on a topic to extract public opinion. For that, you can extract tweets from Twitter. You can track the reputation of a person or a company by importing Facebook and Twitter data. Sentiment analysis, friend analysis, and page analytics can also be performed. An API is a backend interface to which third-party developers may connect new add-ons to an existing service. The API is also an interface for researchers to collect data of a given social media service for analysis. REST stands for Representational State Transfer, and API stands for Application Program Interface. REST is a software architectural style that defines the set of rules to be used for creating web services. It uses HTTP requests to get, put, post, and delete data. A RESTful system consists of a client who requests for the sources such as website, mobile devices, etc., and a server who has the resources. It is important to create REST API according to industry standards, which results in ease of development and increases client adoption. As we all know, Facebook is the biggest social network. And if you are a web miner and you want to access users' account data, that is explicitly available by registering an application and using that application as the entry point into the Facebook developer platform. So the only data that is available to an application is whatever the user has explicitly authorized to access. Go to the link https://developers.facebook.com docs graph API if you want to collect data on anything that is available publicly. To be able to extract data from Facebook using a Python code, first you need to register as a developer on Facebook and then have an access token. Here are the steps for it. Number 1. Go to the link developers.facebook.com and create an account there. Number 2, once you logged in, you get My Apps. Number 3, click on it, you will be redirected to a panel, and here you can create an app and you can get user access token. Shortly, I will tell you about user access token and its use. I have already created an app called Skill Curve for our use. Click it, and this is the particular dashboard of the application. Next, go to the link developers.facebook.com/tools/explorer. You will see Graph API Explorer below My Apps in the top right corner. From Graph API Explorer, drop down, select your app. Then select Get Token. From this drop down, select Get User Access Token. So, what is an access token? An access token is an opaque string that identifies a user, app, or page and can be used by the app to make Graph API calls. When someone connects with an app using Facebook login and approves the request for permissions, the app obtains an access token that provides temporary, secure access to Facebook APIs. Access tokens are obtained via a number of methods, and this is one of them. This is the token. Copy it, and you can use it later in your application. This is my app. There are other apps also, but we are using Skill Curve app for the lesson. Next, we have user page. I'm using the user access token, and here's the list of permissions which I will be discussing shortly. Here is the web interface where you have a get method. Here is the version and the initial fields. Once I press submit, it returns user ID and name. Similarly, I can access other things as well. For example, choose email and it returns email of the profile. Now let me access birthday. But right now, I haven't given any such permission. So from the drop-down, select the permission. Regenerate the access token. Now submit. And here you get the birth date of the user. So after selecting permissions from the menu, don't forget to select Get Access Token. Go to the link developers.facebook.com/tools/access token. Select Debug corresponding to user token. Go to Extend Token Access. This will ensure that your token does not expire every 2 hours. Now let's get back to Jupyter Notebook. First, import Facebook SDK from command prompt. Type pip install Facebook SDK as discussed in the lecture earlier. Now import it here. Run the code. Now it's time to use the user access token. Create a variable access_token and paste the access token as a string. The Graph API is the primary way for apps to read and write to the Facebook social graph. All of our SDKs and products interact with the Graph API in some way, and our other APIs are extensions of the Graph API. So understanding how the Graph API works is crucial. Pass access token and version to the Facebook Graph API. Now let's access the me node. The me node is a special endpoint that translates to the user ID of the person or the page ID of the Facebook page, whose access token is currently being used to make the API calls. So let's access our me endpoint. Access the me node through the graph.get_object. Run the code and it returns the user ID and name as we saw earlier in the web interface. Now I want to access name and hometown. For this, pass user ID to get object method. Run the code and here you get the desired result. Now let's access the user posts. Here is the code snippet. I am using the getObject method passing pages underscore ID. Here we have fields. They are node properties. When you query a node, it returns a set of fields by default. You can specify which fields you want returned by using the fields parameter and listing each field. This overrides the defaults and returns only the fields you specify and the ID of the object, which is always returned. I am setting fields to type, name, created time, object ID. Okay, now print posts. Let me run the code. Some aliasing not existed. Let me check. Okay, so just have to pass user ID, type, page underscore ID, and set user ID. Now run the code. These are the post's details. Now let's suppose I want to access all posts of the year 2019. Here is the code. Here I import datetime library and now using getAllConnections methods, pass the ID and set connection name to posts. Next in the since argument, I pass the year, month, and date. Now let's enumerate over each post using enumerator. This is the result. We can also limit the responses. Limiting allows you to control the number of objects returned in each set of paginated results. To limit results, add a limit argument to any field or edge. Let me show you this. Suppose I want to access 2 recent posts. Using the object method as we did earlier, I just added the limit function. Type p1 equals to recent posts, post, data, 0, and p2 is equal to recent underscore 2 underscore posts, post, data, 1. Print p1 and p2 one by one. You can also find the number of reactions and comments on a particular post. This is how it can be done. This particular post has 2 comments and 20 reactions. And this way, you can access Facebook data using Graph API. In this lecture, I will show you how to import datasets from public source that are available freely for your AI, machine learning, and data science practices. Okay, so we want to perform data analysis, but for that we need data sources to pull data. There are 2 types of dataset. Primary data, data that you create yourself. When you create that data you want by yourself, it's called primary data. If you interview people to gather feedback on your product, the interview data is primary data. Secondary data, data that you collect from someone else. When you collect data from sources that someone else owns, it's called secondary data. If you use data from Google Analytics to understand how many people visit your website, you're using secondary data. It's still data on your organization, but it needs something that a secondary organization, in our example, Google, collected for you. Data comes in several formats. Here's my quick take on the 2 most prominent ones. Structured data. Unstructured data. Data without any particular format. Think of surveillance data. Gartner estimates that more than 80% of enterprise data is unstructured. If you're an expert data analyst, you need to create data sets by yourself. But if you're new to the field and learning data analysis and data science, then you can grab data sets from free and public data sources that we will share shortly. You can download a data set from public data sources from various popular formats. These include Kaggle, UCI Machine Learning Repository, 538, and academic torrents. Kaggle allows users to find and publish datasets, explore, and build models in a web-based data science environment, work with other data scientists and machine learning engineers, and enter competitions to solve data science challenges. We have different government sites that share public datasets such as data.gov. Here you will find data, tools, and resources to conduct research, develop web and mobile applications, design data visualizations, and more. Search.gov is a service of the General Services Administration, providing search engine capability to federal agencies for their public website. The UCI Machine Learning Repository is a collection of databases, domain theories, and data generators that are used by the machine learning community for the empirical analysis of machine learning algorithms. It has more than 500 data repositories on different domains such as health, energy, finance, etc. Web scraping is a term used to describe the use of a program or an algorithm to extract and process large amounts of data from the web. Whether you're a data scientist, engineer, or anybody who analyzes large amounts of data sets, the ability to scrape data from the web is a useful skill to have. Let's say you find data from the web and there's no direct way to download it. It can be done both manually and automated. If you copy data from a website into a file, then it is manual scraping. And if you use any tool or software to grab data from the web, then it is called automated scraping. Automated web scraping using Python is a skill you can use to extract the data into a useful form that can be imported. We will extract job information from monster.com using Python. But first, let's get an idea of what a web scraper and crawler is. Web scraping is composed of two components, a crawler and a scraper. Have you ever wondered how Google searches and finds a website? Before ranking first, the website is found using web crawlers using algorithms. A web crawler or a spider is an artificially intelligent that browses the internet to index and search for content by following links and exploring. The use of web scraping for businesses and personal requirements are endless. A web scraper can be used for market analysis by gathering contact details of businesses or individuals from websites like yellowpages.com or linkedin.com. Details like email addresses, phone, website URL, etc. can be easily extracted using a web scraper. It can be used in sentiment analysis of movie reviews or product reviews, for news gathering, price monitoring, for research, and the list goes on. There is a tremendous amount of data available on the internet. To effectively harvest it, you need skill of web scraping. Web scraping is the process of gathering information from the internet. Even copy-pasting the lyrics of your favorite song is a form of web scraping. However, the words web scraping usually refer to a process that involves automation. It automatically extracts data from internet sources and presents it in a format you can easily make sense of. Today, we'll learn how to use request and beautiful soup for scraping and parsing data from the web. Walk through a web scraping pipeline from start to finish. And build a script that fetches job offers from the web and displays relevant information. Suppose you are looking for an employment opportunity. However, you are not looking for just any job. You are waiting for the perfect opportunity to roll your way. Instead of looking at the job site every day, you can use Python to help automate the repetitive parts of your job search. Automated web scraping can be a solution to speed up the data collection process. Say, I am looking for software developer jobs listings from the Monster job website. Let me show you. So, click on monster.com for Canada and we are looking for software developer job. Now, search it. And here's the list of job openings. If we inspect the page, we get the HTML tags from which we are going to parse our information. Our web scraper will parse the HTML to pick out the relevant pieces of information and filter that content for specific words. First, install Beautiful Soup from command prompt pip install Beautiful Soup 4 as discussed in the lecture. Next, import necessary libraries. To access HTML elements, you can request libraries. Run the code. These libraries are now part of your application. Now access the website here. Pass base URL monster.com to it and now create a page object. To access the page, type request.get and pass base URL with the query parameters. Any job you'll search for on this website will use the same base URL. However, the query parameters will change depending on what you are looking for. It retrieves the HTML data that the server sends back and stores that data in a Python object. Now, I'm going to use Beautiful Soup. Beautiful Soup is a Python library for parsing structured data. It allows you to interact with HTML in a similar way to how you would interact with a web page using developer tools. To access the page content, type soup equals to page.content html.parser. Now we access the page element. Beautiful Soup allows you to find the specific element easily by its ID. Here we want to access result container which contains job listings. Now I want to print first 5 rows to perform sanity check. Access the div element. Access them using slicing method. These are the top 5 rows. We have multiple divs. This is not much readable. For easier viewing, you can .prettify any Beautiful Soup object when you print it out. If you call this method on the result variable that you just assigned above, then we can get a much more readable format and can see all the HTML contained within the div. You have seen that every job posting is wrapped in a section element with the class card content. Now you can work with your new Beautiful Soup object called results and select only the job postings. These are, after all, the parts of the HTML that you are interested in. Run the code. Here we have an incorrect syntax. Let me add underscore here and correct it. So now we get the all job elements. This particular job element is an iterable. Now iterate through each element using loop. Run the code. You get the data value company name, location name is there. We are moving toward cleaning off our result data. Let me add a code snippet. Run the above code snippet and you'll see the text content displayed. Here we used find method to search for these particular elements only if there is no match found in these tags. Then continue, otherwise strip the value of tags and print it. Area Supervisor is the title. Ross Stores Incorporated is the company. Pikeville, KY is the location. This is how you get better results. Every site has a different structure, so it is very important to know the structure of the site first before scraping. In this tutorial, you performed scraping using beautiful soup library in Python to parse HTML data for further analysis. Hope you enjoyed it. After all, it is all about what you can do with the data you have collected and how valuable you can make it. Hello and welcome to Data Preparation, Section 6 of our course. As we know by now that data comes from a wide range of sources and in different formats. Despite the heterogeneous nature of data, when it comes to dataset, everything is in the form of numbers, be it textual data, statistical values, or images. Digital images can be thought of as simply two-dimensional arrays of numbers representing pixel brightness across the area. Sound clips are the numerical arrays of intensity in a time series fashion, and so on. Regardless of what the data are, we have to convert it into numbers before analyzing it. And for this reason, efficient storage and manipulation of numerical arrays is a must to the processing of doing data science. We'll look at the specialized modules that Python has for handling such numerical arrays, the NumPy and the Pandas modules. This section will cover the NumPy module needed to manipulate the dataset. It was one of the core modules used in the data sciences processes. So let's spend some quality time on learning it. To work with our datasets, we'll be utilizing an incredible Python module known as NumPy, which is a short name for numerical Python. It is one of the core libraries for numeric and scientific computing in Python. It is extremely fast when compared to core Python thanks to its heavy use of C extensions. Many advanced Python libraries such as scikit-learn, scipy, and keras make extensive use of the NumPy library. Therefore, if you plan to pursue a career in data science or machine learning, NumPy is a very good tool to master. NumPy comes with a variety of built-in functionalities. Coming to NumPy arrays, its main object, NumPy arrays are similar to Python's built-in list type that you have learned in Section 4. But NumPy arrays provide more efficient storage faster to perform data operations as the arrays grow larger in size. Anaconda is pre-installed with NumPy library, but if you're using some other editor, you can install it by typing command pip install numpy. To use NumPy library in your Python program, type import numpy and give an aliasing to it such as np. Effective computation and data analysis requires understanding how data is stored. This can be achieved by understanding data types. This section outlines the data types used provided by NumPy. Suppose Tom wants to store the student marks in a spreadsheet. So what data type comes into the mind? Marks are whole numbers and can be stored in an integer data type. Similarly, fees and salaries are floats. Weather data for predictions is a number crunching process and can be stored in double. Here is a list of common data types supported by NumPy: bool, short, int, and double, followed by float, complex, and unsigned integer. Because NumPy is built in C, the types will be familiar to users of C, Fortran, and other related languages. Let's have a taste of using NumPy in Python by first creating an object of type integer and next finding the size of the data type using item size. Afterwards, we will print the name and size of the type. NumPy has many uses, which includes efficiently working with many numbers at once, generating random numbers and performing many different numerical functions such as mathematical, trigonometric, array creation and manipulation methods, log, and exponential functions, statistical methods, etc. This example uses an array and trigonometric function to plot a sine curve using NumPy. NumPy arrange function is one of the array creation routines based on numerical ranges. It creates an instance of any array with evenly spaced values and returns the reference to it. Now don't worry about arrays and the functions used right now. We will be discussing it in the later sections. Think of an array as a list by now. Here, X generates an array Y calculates the sign value of each element present in the array. And next, we plot the values using the visualization library Matplotlib. Let's talk about NumPy arrays. NumPy arrays are like built-in Python lists. But unlike lists, only single data elements can be stored in a NumPy array. It gives users the opportunity to perform calculations across entire arrays. They are faster than lists and provides efficient storage. A NumPy array is a grid of values of fixed size, all of the same type, and is indexed by a tuple of positive integers. The number of dimensions is the rank of the array. Okay, let's look closely to an array structure. In NumPy, the number of dimensions of the array is given by rank. In the first example, we have a 1D array that can store a sequence of single list values. In the second example, we have an array of rank 2 as it is a 2D array with multiple rows and columns. Suppose we want to store multiple marks of 10 students. For this, 1D array is not sufficient. We have to use a 2D array, where each row corresponds to a student and columns refer to its marks in different subjects. An array is composed of different attributes. Number 1, name. It defines name of an array object. Number 2, size. The total number of elements in an array. Number 3, shape. The shape of an array. Number 4, dimension. The dimension or rank of an array. Number 5, dtype. Data type of an array. Number 6, item size. Size of each element of an array in bytes. N bytes. Total size of an array in bytes. Especially for larger arrays, it is more efficient to create arrays from scratch using routines built into NumPy, such as arrays of ones and zeros. Here in first example, we are creating a 2D array of size 2 by 2 having all zeros, as you can see the output. Next, we are creating with all ones having rank 2 and size 3 by 2 means 3 rows and 2 columns. We can use np.array to create arrays from Python lists. Next, we find the attributes of the array, myArray. Let's see the output of it. Okay, let's see how it works in Jupyter. Unlike Python lists, NumPy arrays can explicitly be multidimensional. NumPy.ndArray is a class, while NumPy.array is a method to create ndArray. We can also use ndArray and explicitly define data types of elements to create an array of any shape. An array can also be created from lists and tuples, as you can see it in the next two examples, where list and tuples are passed as parameters to functions np.array. Here is the output. 3 arrays are created. Now let's do this in Jupyter. Let us explore some NumPy array functions. After creating an array, the first thing that comes into mind is how to access elements individually rather than printing the whole array elements. Here we have an array of heights in centimeters with 6 elements and rank 1. You can use positive integers in indexing to access elements. The index starts from 0, so to access second element from the array, call array and pass 1 in square brackets, which results in 97. In a similar fashion, elements in a 2D array can be accessed. Simply pass row number and column as parameters in square brackets. To access an element present at first row and second column, pass 0 and 1 as index values. Likewise, Element at third row and third column can be accessed by passing 2 as index values. We have seen arrange earlier. Now take a closer look at the function and associated parameters. This function returns an end-array object containing evenly spaced values within a given range. Format of the function is as follows. numpy.arrange first parameter is start value. Next step is ending value third, one is step value, and last parameter can be used to declare data type of elements. The last two parameters are optional and can be skipped if not needed. Now, create an array of even numbers starting from 10 till 20 with 2 as a step value. If you are familiar with Python's standard list indexing in NumPy will feel quite familiar. 3 methods are available for indexing. Field access that we have seen earlier to access any element. Also to index from the end of the array you can use negative indices as well. -1 returns the last array element. Second is slicing and third is advanced indexing. Now moving to basic slicing. Just as we can use square brackets to access individual array elements, we can also use them to access subarrays with the slice notation using semicolon. Basic slicing is done by giving start, stop, and step parameters to the built-in slice function. The slice object is passed to the array to extract a part of the array. Use slice method or use semicolons in a square bracket. Here we want to extract a part of an array containing integers from 0 to 10 starting from index 2 till index 7 having a step value of 2. The output returns 2, 4, and 6. It is not mandatory to provide all 3 parameters here. We are slicing from index number 2 till end with a single step as seen in the output. If you want all rows but a second column, you can slice the array by providing 3 dots initially, which shows all rows, and after comma, pass 1 to fetch the second column. Now to access the second row and all column, type 1, 3 dots. Finally, slice all items from column 1 onwards. This example demonstrates how to slice first 3 elements from a 1D array. Now to slice elements after index, any particular index, you can type that index number followed by a colon and an empty value. To slice every other element, use double colons. A potentially confusing case is when the step value is negative. In this case, the defaults for start and stop are swapped. Negative indexing can also be used to reverse all elements from an array. Type double colon followed by -1. AsArray is another method that can be used to convert a list into a NumPy array. Simply pass the name of the list as an argument to it. As you can see here, the list A is converted into a NumPy array. In the previous sections, we discussed NumPy arrays and functions. Now it is time to explore operations that can be performed on arrays. NumPy's main object is the homogeneous multi-dimensional array. Multiple operations can be performed over it, such as mathematical operations, converting the shape of the arrays, iterating the elements, joining 2 or more arrays, appending arrays, splitting it into multiple arrays, and performing broadcasting operations on it. Coming to mathematical operations, you can perform element-wise operations on arrays of the same shape. We can perform all basic mathematical functions using NumPy. Let us have a look at them in the lab. Using NumPy, you can modify the shape of an array. For example, you can convert a one-dimensional array into a two-dimensional array using the reshape method. You can also iterate through elements of an array using anditer in a loop. If you want to modify contents during iteration, use op flags in the parameter. Moving on to joining one or more arrays together. It can be performed using the concatenation method of NumPy module. The concatenate method joins a sequence of arrays along an existing axis. However, you can pass the axis in parameters. Now let's check this in Jupyter. The append function is used to append values to the end of a given array. This function returns a new array and the original array remains unchanged. The syntax is the R can be an array like object or a NumPy array. The values are appended to a copy of this array. The values are like objects and it's appended to the end of the R elements. The axis specifies the axis along which values are appended. If the axis is not provided, both the arrays are flattened. Splitting is the reverse operation of joining. A single array can be split into multiple arrays. You can split an array by specifying the number of equally shaped arrays to return or by providing columns. It is also possible to do operations on arrays of different sizes. If NumPy can transform these arrays so that they all have the same size, this conversion is called broadcasting. In broadcasting, the smaller array is broadcast to the larger array to make their shapes compatible with each other. The first rule of broadcasting is that if all input arrays do not have the same number of dimensions, a 1 will be repeatedly prepended to the shapes of the smaller arrays until all the arrays have the same number of dimensions. The second rule of broadcasting ensures that arrays with a size of 1 along with a particular dimension acts as if they had the size of the array with the largest shape along the dimension. The value of the array element is assumed to be the same along the dimension for the broadcast array. Or arrays with a 1 along with a particular dimension act as if they had the size of the array with the largest shape along that dimension. The value of the array element is repeated along the dimension. After application of the broadcasting rules, the sizes of all arrays must match. Now, I am about to explain these rules in lab. Now, move to NumPy arrays. Create a 1D array, say 1, 2, and 3. Now, print this number array. I can also create an array of complex numbers. For example, these are my complex numbers. Just pass parameter dtype to complex. Run the code and it returns 3 complex numbers. This is my first complex number, this is second, and this is third. NumPy provides us a facility to quickly create an array of zeros by simply accessing the method zeros. Let me create one. Zeros array is equal to np zeros. Next in parameter list, pass the dimensions of array, that is 2 by 2, and set the dtype to integer. Run the code and you get a two-dimensional array of zeros. Similarly, you can create a one-dimensional array of zeros. For example, Copy it, paste it here, rename it, and instead of list in the parameter, pass a scalar value 2. It will create a 1D array of zeros having 1 row and 2 columns. And here we have 2 rows and 2 columns. We will discuss more about 2D arrays in a while. Now we can also have array of all ones. Let's say we need an array of 3 by 2 of type integer. Next, print this array. Ones array. It returns a 3 by 2 array that is 3 rows and 2 columns. Now it's time to learn more about properties of arrays. Here is a code snippet as discussed in the video lecture earlier. It is used to display type, shape, dimensions, size, and type of each element of an array. Here we have an array of 3 by 3 that is 3 rows and 3 columns, so it is basically a two-dimensional array. You can get the shape of an array using this. Now run the code and it returns. It displays the array elements, its type, shape, which is 3 by 3, rank 2, size 9, as there are 9 elements present and data type of element present in the array, which is integer. Let's create an array using ndArray method, which is a shorthand name for an n-dimensional array. When working with NumPy, data in an ndArray is simply referred to as an array. It is a fixed size array in the memory that contains data of the same type, such as integers or floating point values. Now set parameters as discussed. First, I'm giving shape parameter next data type float. Print the array, which represents the random numbers array of rank 2 and type float. You can also create an array from a list. For example, here I am creating a 2D array, pass a list to np.array. So this is another method to create an array. Next, print it. Okay, so data type error. Oops, square bracket is missing. Run the code and you get a 2D array from a list. This is our first row and this is going to be our second row, separated by a comma, and all this is enclosed in a square bracket representing a list. Similarly, we can use tuples to create an array. Copy the code and instead of list, pass a tuple. Here we have 1D array from a tuple. Now it's time to access the elements of an array. For example, I just stored the student's height in centimeters using an array. Pass the list of numbers to NumPy array method. Now I want to access the first element of the array. Use indexing. Pass 0 as an index, as we all know that indexing of an array starts from 0. Here you get the first element. Similarly, you can access any element, for example, pass 2 to access third element. Now switch the gear to multi-dimensional array. First, we need a multi-dimensional array. So we are using numarray2 here. Let's print the element 2. At row 0 and column 1, we have element 2, so we got 2 in the output cell. Similarly, to access 6, you have to type 1 as it is in row 1 and column 2. So you get 6. This is how elements can be indexed. It's time to learn array operations. First, I'm going to discuss addition operation. Declare an array using Numpy array method. Now for second array, copy it, paste it here, change the values and names. If you want to perform addition element-wise, then simply use plus operator. Print your first array, then add them with the second array. In other languages, we have to run a loop for this, but here, mathematical operations are just that simple. Run the code and you get an array which contains element-wise sum. In the same fashion, you can perform subtraction, multiplication, division, etc. I am leaving that to you as an exercise. We can also reshape an array. For example, consider this array R and use it to perform reshape operation. Rename to R3, and instead of a 3x3 array, I am using a 2x3 array. Next, print it and call reshape method. We get a reshape array of dimensions 3x2, 3 rows and 2 columns. Your original array shape remains same. We can also iterate through array elements using nditer. Run a loop, pass your array to nditer method, and print each element using variable x. And this way you can traverse through array elements. Moving to split operation, create an array using arrange method. It creates an array of random elements of size 9. First, we split the array into 3 equal subarrays by using split function. The split function takes 2 arguments array and number of splits. We can also perform splitting at a particular index location. But first, just look the equal size subarrays results. Here we're splitting at index 4 and 7, leaving the rest unsplit. This is your first array of 9 elements. Next, we got 3 equal splits. That is 0, 1, and 2 belongs to the first array, whereas 3, 4, and 5 belongs to the second, and 6, 7, and 8 belongs to the third array. Next, let's see the splitting at defined index locations. Run the code. The first split occurs at 4th index. Joining is performed along axis 0. Here, we have 2 arrays of 2x2. Next, join them together using concatenate method. It will join 2 arrays on axis 0. Run the code and see the result. If dimensions of both arrays are different, then you will run into syntax error, as I did here. Let me correct it. Row-wise concatenation has been performed. You can also perform this joining along y-axis. Set axis is equal to 1. Earlier, we saw that arrays can be added together with a single operation. This is called broadcasting. So let's discuss broadcasting in detail. Here, we have 2 arrays, A and B. Print both arrays and next add them together using plus operator. Similarly, perform subtraction. This is the result of subtraction. Last but not the least, we can also visualize the array points using Matplotlib library. First import the library Matplotlib. Then create an array. Later, find the sign value of it. Now, plot the sine curve. So this is all about NumPy library. Hope you enjoyed the session. Coming to another powerful and most frequently used library in Python, Pandas. It is built on the top of the NumPy package which we just learned in our previous section. In this section, we will go over the essential bits of information about Pandas, including how to install it, its uses, and how it works with other common Python data analysis packages such as NumPy and Matplotlib. Pandas stands for Python Data Analysis Library. The Pandas package is the most important tool at the disposal of data scientists and analysts working in Python today. It is the backbone of most data projects. It provides fast, easy, and flexible data structures to manipulate and analyze data. Moreover, it delivers optimized performance when working with C language or Python backend codes. So those interested in data analysis, modeling, and visualization must learn Pandas, as it is the best avenue to learn the nature of your dataset before modeling or analyzing it. First, install the package Pandas from command prompt using command pip install pandas. In Anaconda, it is pre-installed, so if you're using it, then simply import the package in your Python program. It can be imported in your application with aliasing PD. Throughout this tutorial, you will find the same aliasing for Pandas modules. You can find the version using command pd.double_version_double_. It has so many uses that it might make sense to list the things it can't do instead of what it can do. Through Pandas, you get acquainted with your data by cleaning, transforming, and analyzing it. Pandas can extract the data from that CSV, Excel, JSON into a data frame, which is like a table. After extracting, we can then perform statistical operations on it to get a better understanding of our data and its nature. Later, we can visualize it as data from Pandas can be easily fed to other libraries such as Matplotlib for plotting results. Finally, data can also be stored in different formats, which you will see in the next lesson. Any type of tabular or CSV data, such as patient CSV file, that can hold different data types, say int, float, string, date, etc. Time series data for analysis can be fed, such as stock exchange data for analysis and prediction. Any metrics data or observations recorded in any format can be an input to it. There are two core components of Pandas, series and data frames. Let's talk about them. Series is like a one-dimensional array or a column with axes, labels, or indexes. Here data can be a scalar value, which can be an integer or a string value. A Python dictionary of key value pairs, or a ND array. On the other hand, Pandas data frame is a multi-dimensional array made up of a collection of series and has multiple rows and columns. Data frame can be one or more dictionaries, one or more series, 2D NumPy ND array. Let us see how it looks. This is a data frame consists of multiple rows and columns, can be viewed as collection of multiple series. Also, it has an index associated with it. Data frames and series are quite similar in that many operations, such as filling in null values and calculating the mean, but first we have to learn how to create them. First, create a list of numerical values as data, now called Pandas function series, and pass the data to it as a parameter. This is how you can create a simple series from scratch in Python using Pandas. You can also define custom indices to it by passing the index list to the function along with the data. Let me show you how to perform it in Jupyter. Define two arrays D1 and D2 of rank 2. Then pass these as values to a dictionary, data, and next pass it to the Pandas function data frame. It will create a data frame from scratch. You can also load a predefined data in a CSV file as a data frame. Here you can see the very popular iris dataset load as data frame. Sepal length, width.petal length, and width along with the class are all columns, whereas the first column is the default index. Now it's time to create and load data frames in Jupyter. In this section, you will find out how to load and store data in different data formats using Pandas. So let's get started. From the last lecture, you are already familiar with importing data from a CSV file simply using read_CSV method and load the dataset from further processing. In this example, I have loaded a CSV data of student grades and passed all column names in the form of a list as arguments to the method. You can also store data frame in CSV format once you finish working with it using the method _CSV. If you don't want the index column in the save file, use property index equals to false. Otherwise, simply don't use this property. Now, I'm going to perform an example in Jupyter Lab. Excel files are very common in the business world to store information about day-to-day activities or records about products, processes, inventory, etc. Excel data can be imported in Python using Pandas through read_Excel method. This example shows the basic syntax of the method. You simply have to pass the name of the spreadsheet file to it, and Pandas will convert it into a data frame automatically. Moving to a popular data format in the internet world, JSON. JSON stands for JavaScript Object Notation. It is very famous in the internet world as it is lightweight and is very easy to transmit data over it. Most of the APIs are using this format for data exchange. It is based on a collection of key-value pairs like dictionary that you have seen earlier. We can read a JSON file using read_JSON method, and Pandas returns a data frame. Let's see a JSON file. Open a JSON file. Cars is equal to name, Honda, price, 1000, model 2005, power 1300. Name, Toyota, price 12,000, model 2010, power 1600. Name, Audi, price 25,000, model 2017, power 1800. Name, Ford, price 28,000, model 2009, power 1200. This is how you can load a JSON file in your Python program. The head method is used to display top 5 records of the data frame. Data frames can be stored back to JSON format too by using the most usable to underscore JSON function of Pandas. Welcome back. Pandas library provides a number of functions that can be applied to data frames. Common functions are selection, indexing, filtering, concatenating, merging, and reshaping data frames. Let us look at some of them in the Jupyter Lab. Reshaping your data frame is transforming it so that the resulting structure makes it more suitable for your data analysis. In other words, reshaping is not so much concerned with formatting the values that are contained within the data frame, but more about transforming the shape of it. From pivot method, you can create a new derived table. The method takes three inputs: your data frame, columns, and index. I will show you how it works on a data frame. We have stack and unstack method. When you stack a data frame, you make it taller. You move the innermost column index to become the innermost row index. You return a data frame with an index with the new innermost level of row labels. The reverse is unstacking. Much like stack, you use unstack to move the innermost row index to become the innermost column index. Isn't it confusing? Let me show you what does it actually mean. Coming to the last lecture of this section, regular expressions. Diving headlong into data sets is a part of the mission for anyone working in data science. Often, this means number crunching, but what do we do when our data set is primarily text-based? Instead of doing data cleaning manually, we use regular expressions in Python, saving you the trouble of having to search through mountains of text by hand. Regular expressions can be used across a variety of programming languages, and they have been around for a very long time. Regular expressions regex are essentially text patterns that you can use to automate searching through and replacing elements within strings of text. Python uses regex module re to analyze text strings. You can import it in your Python program using command import re. Okay, now have a look at some common re methods. First is search. If you want to find first occurrence of a pattern in a text, you can use it. Second is match. It returns a match object if found in a text. Find all returns a list of instances of a pattern in a text. Sub is used to replace one or many matches with another text. Split comes very handy to split a long text at a match, such as to split web URLs from a text. What to enter in the pattern argument? Here are some regex patterns used commonly. \w is used to find a match of words. For example, in a text of numbers and words, it returns words only, for example, magic 6. The \w will return magic. Similarly, to get digits only as a match, use \d. It returns 6 from text magic 6. S is used to find space. Dot asterisk is used as a wildcard pattern which matches all. Capital S is for no space. And you can also specify group using brackets. In brackets, you can form appropriate groups for match. For all lowercase, use A to Z. For all uppercase, use capital A to Z. Range can be specific too, like to find only A, B, and C type pattern, A-C. To create a range of digits from 0 to 9, use 0-9. Also, you can create a mix of digits, letters, and special characters. Let's do some magic in Jupyter. In this section, you get familiar with two important libraries, Numpy and Pandas. Data science skills encompasses exploring, cleaning, transforming, and visualizing data for perfect modeling. Also for data parsing and pattern matching, we explore regular expressions. In the next section, we will go through data profiling and exploratory data analysis. So let's talk about pandas in Python. As we discussed in the video lesson that we can analyze data in pandas using series and data frame. Series can be data of scalar value or a Python dictionary or a 1D array. On the other hand, data frame can be one or more dictionary or a series or an ND array. So let's begin. First, we have to import pandas library. Here, PD is used for aliasing. Next, print the version on pandas that I'm going to use, which is 0.24.2. Now it's time to create series from scratch. Here I declared a numeric list of values from 1 to 6. Next, I call pandas series function to convert the list into a series data structure. Finally, I print the series. Notice in the output cell that we have two columns. The left column indicates the default index number, while the right column represents the series values. We can give index values by ourselves. In the next code, I have created a list of index values. Again calling the series function, but this time with data and index both. Print and get results in a series of values with the defined index values. Okay, now create a series using NumPy methods. First, I imported the NumPy module. Next, I called the random method to generate 10 random values and pass it to the series function. Print and get results in a series of 10 random values. We can also use NumPy repeat method to repeat a value or a set of values. Here I passed 0.5 and I want it to be repeated 6 times. Later, I wrap the result in a series method so the resultant is a series of 0.5 repeated 6 times. This is how you can create series from pandas library. Now moving on to data frames, which is our main agenda. A data frame is a two-dimensional data structure and it is an in-memory object. To create a data frame from a list, dictionary, and dimensional array, we use data frame method from pandas. Here, I provided a dictionary having cities and provinces as key values. Later used the pandas data frame function to convert it into a data frame named frame1. This is a data frame in the output cell. You can also load a data set in a data frame for further processing. Here I load an iris data set which represents the flower measurements using read_CSV method. I pass the column name to it from a list. This is how a data set can be loaded into a data frame. The read_CSV method loads data set into this particular object. Later, I called it. The output displays the iris data set with given column names. That is sepal length, sepal width, petal length, petal width, and class. Let's discuss about importing and exporting different types of data sets. First, I want to discuss importing and exporting CSV files. We can use pandas read_CSV method to load a CSV file into a data frame as we did earlier. Now I displayed the top 5 rows using the head method. So these are the top 5 rows and these are the columns. Next, if you want to save data frame into a CSV file, you can use the CSV method. First, I created a data frame from a dictionary and later exported it into CSV using to_CSV. I also passed the column's name to it, brand and price. Also, parameter index is set to false, that is index of data frame should not be saved, and set header is equal to true to set column names. Later, I print the data frames too. Here is the data frame with default index and brand and price columns with data values. Let me show you the CSV file. See, index is not a part of it. It only contains the brand and price column with data values. Let's get back to Python. Again, I want to reiterate that index is not saved. Now, let's move to Excel data format. First, I imported the Excel data of university students using the method read_Excel and passing the Excel file name to it with extension. Next, print the top 5 rows of my loaded data frame. See, it's very easy to import an Excel file. We can also import data frame into Excel file using to_Excel method. Here, I exported the tip.csv file data frame that we loaded earlier into an Excel file named output_Excel. And next, printing the top 5 rows of it. Let me show you both Excel files. This is the file data that we imported earlier using read_Excel method. And this is the exported Excel file, the one with the tips dataset. Now importing JSON data. Here I'm going to read a product file written in JSON. In JSON, we have key value pairs. The read_JSON load JSON data into a Pandas data frame. Next, I use the head method to explore the data values. So this is the products.json file. Next, before exporting, I filtered products based on price. Say, if price is greater than $500, then retrieve such products and create a new data frame from it. First, access the column of your data frame, next pass the condition in the square brackets. So this is the new data frame. Now I call the to_JSON method to save my data frame in JSON format. Pass the file name with extension JSON. See the file. It contains only those products that have price greater than $500. Pandas provide a variety of functions that can be applied on data frames. First, let's load the dataset using read_CSV method. Here, I loaded the tips.csv file with the restaurant's billing information. Name of my data frame is df_tips. Next, we have two functions to explore it. The head function returns the top 5 rows of a dataset. So these are the top 5 observations. Whereas tail represents the last 5 rows, as you can see in the output cell. We can also find the name of all features using the column property. Call your data frame with column property. It returns the name of all columns from the dataset. You can also access a particular column by accessing the column name after a period. So it displays the day column only. Moving to indexing and slicing. There are multiple ways to select and index rows and columns from Pandas data frame. We have lock and ilock methods. Suppose I want to access time column and all observations. In lock, I pass 2 parameters, row selector and a column selector. To get all rows, use colon operator with no start and ending index number. And in column, I pass the column name only. See the output cell? All observations of time columns are displayed. Next, move to ilock. The ilock indexer for Pandas data frame is used for integer location-based indexing or selection by position. ilock in Pandas is used to select rows and columns by number in the order that they appear in the data frame. Note that .ilock returns a Pandas series when one row is selected and a Pandas data frame when multiple rows are selected, or if any column is full is selected. When selecting multiple columns or multiple rows in this manner, remember that in your selection, for example, 1:5, the rows or the columns selected will run from the first number to 1 minus the second number. So here I'm accessing all rows and second column of data frame. Similarly, you can access all desired rows and columns. Here it is displaying the total bill column. Now I want to access top 5 rows and all columns. So pass 1:6 and in column selector pass a colon only. So you get the top 5 rows with all columns. Next, filtering. Suppose I want to extract female customer orders. So access the sex column and equate it with female and set it as a condition in the index position. Next, I pick the top 10 values using head function. You can also fetch all values by removing this head function. In the same way, data of male customers can be accessed. Moving to Boolean indexing. What do you do if you want to filter values from a column based on condition from another column or a set of columns? This can be done using Boolean indexing. Suppose you want to find the list of female customers that had their lunch on Sunday. Create a data frame. Yes, using AND operators as it is necessary to meet all three conditions. Next, I pass the output as Boolean indexing to my data frame. The result displayed the desired result. But what is the val variable? Let's print it. It returns true or false against each observation. So this Boolean result is passed for indexing. We can also find unique values from a particular column. Suppose I want to know the unique values present in the sex column. The code returns male and female. Similarly, you can access any other column, say for example time. It returns lunch and dinner. We can also get duplicate rows using duplicated method. Here we have no duplicate rows, so it returns null. Moving to iteration. Create a data frame with columns A, B, and C. This is our data frame with columns A, B, and C. We can fetch each data frame element one by one using method iterRows. Apply a for loop to sequentially access data. The iterRows method returns row and index. I use row and call column names to access individual elements. So we get 1, 2, 3 from first row, 4, 5, 6 from second, and so on. Moving to concatenation operation. We can join two or more data frames using concat method, which results in a new data frame. Here I declare two data frames which has been created from dictionary, frame 1 and frame 2. Printing them, both contains same columns, city and provinces. Now using Pandas concat function to concatenate them. Here I use drop_duplicates method to remove duplicate values and reset_index method to reset default index values. We have Karachi as value in both dataset using drop_duplicate method. It is not repeated twice in the final data frame. Also, sort is set to true to perform default sorting. If I remove reset_index method, the index number of both data frames remain intact, and you can see that 0, 1 is repeated again. Let's move to sorting. Use column name that you wish to be sorted in the sort_values method. Here, provinces is used. Now, the output cell displays the provinces in ascending alphabetical order. You can change the column name to cities and see the effect. We can also combine data frame based on values in shared columns. This is known as merging. It offers more flexibility compared to concat as it allows combinations based on a condition. Here I am merging frame 3 and data 3 based on provinces as this is a shared column. See the result. Province column is not repeated. Here is the result. Quetta is the city, province is Balochistan with 12.34 million population. Again, checking filtering. We can filter results based on a particular value only. Say, I want to see the result of data with Lahore as city. Pass this condition to the data frame. Next, move to pivoting. The pivot function is used to reshape a given data frame, organized by a given index or column values. This function does not support data aggregation. Multiple values will result in a multi-index in the columns. First, create a data frame from a dictionary. The restaurant data frame has columns: mobile, store price, and ratings. The pivot function returns reshaped data frame. It requires three parameters: index, columns, and values. An index parameter pass column to make new frames index. If none, the method uses the existing index. For columns, pass column you want to make new frames column. This parameter is mandatory. Lastly, for values, pass a column or multiple columns for populating new frames values. If not specified, all remaining columns will be used and the result will have hierarchically indexed columns. Here I passed index is equal to mobiles, columns is equal to store, and values is equal to price. So at index position, mobile names are displayed. For columns, we have store values. And price is used to fill the values for the data frame. So Amazon and Walmart are columns. We have NEN values where there is no value in original data frame. To see hierarchically indexed columns, remove value parameter from the list. And now a hierarchy is generated in column. As you can see, Amazon and Walmart as column is repeated twice, first for price and next for ratings. We can also use stack method to stack the rows values vertically. Use the stack method provided by Pandas. And see each observation is returned as a stack. You can stack the values using unstack method, using the same stacked result. I applied unstack method over it. Now we get a tabular representation. Melt function is used to unpivot a data frame from a wide to long format, optionally leaving identifiers set. This function is useful to get a data frame into a format where one or more columns are identifier variables, while all columns considered measured variables are unpivoted to the rows axes, leaving just two non-identifier columns, variable and value. In id_vars, we can pass tuple, list, or nd array. It is used as identifier column. All the remaining columns are treated as values and unpivoted to the row axes, and only two columns, variable and value. Here I passed a list having mobile and price in id_vars parameter. In the result, we have these two as column. We can pass the var_name and value_name parameters to change the column names of variable and value. Moving to append operation. I can append one or more data frame with another data frame. First read two data sets and get two data frames, df1 and df2. Next, I appended df2 and df1, setting sort to true. Both data frames have same column names. And the resulting data frame values are appended along axis 0. Both df1 and df2 remains unchanged. Indices can be reset using reset_index method as seen earlier. We can add a new column to existing data frame. Suppose I added a column D in the existing data frame with these values. Print the data frame and see a column D is added. Similarly, rows and columns can be deleted too. To drop a column, set axis is equal to 1. I want to delete column C from my data frame. See the output? Now C column is gone. We can also remove a row by setting axis is equal to 0 and providing row number in the index. Now the row at index position 4 has been removed. Missing values can be filled using fillna method. Here in column B, I want NEN to be filled with double hyphen. Similarly, for column D, I want missing values to be replaced with 0. See the results. We can also replace values from a data frame. Load an Excel file containing students' progress. It has a column grade, having values A, B, and C. Now I want to replace them with numeric entries as it is often required in data analysis. Use the replace method provided by Pandas. Access the desired column first. To_replace method passes the values that needs to be replaced and in value arguments pass the new values. See now, A is replaced with 0, B with 1, and C with 2. You can also use not equals to operator so that observations is not removed but doesn't appear in the result. Suppose I want data of all students except the data of POH, so use not equals to operator. We can also find mean and other statistical values. Here I found the mean of the marks column in the mean value. We can also generate group by and crosstab results similar to group by query in SQL and crosstabs and pivot tables in Excel. Once again, load the tips dataset. Suppose I want to see the difference of mean values of features between smokers and non-smoker customers. This is how it can be achieved. Let me drop this unnamed column. Now group the data in similar manner, but with sex 2. Now we can see the difference of values of smokers, male and females, and non-smoker males and non-smoker females. We can unstuck the value to see in wider format. We can also get a summarized result using pivot table. This is the mean value of tip. We can also find the mean value of tip according to day and time. Finally, using crosstab, I get the count of customers in each day. This is general overview of pandas and functions. Hope you learned a lot from it. Regular expressions are very useful for extracting information from text such as codes, logs, sheets, and even documents. While using the regular expression, the first thing to recognize is we are dealing with characters and strings. On this lab, you will learn the regular expression syntax and methods through which you can extract text based on patterns. A regular expression is an object that describes a pattern of characters. In Python, a regular expression is denoted as RE. The first thing is to import the module RE. Every module included with Python primarily used for string searching and manipulation, also used for web scraping. Now it's time to discuss some of the regular expression methods. So let me define a text. Skill curve data analysis and visualization. Next, I'm going to define the search pattern data. Next, I'm going to search for this particular pattern in my text using the search method. And when I run the code, it returns a match object, says it found a match. It returns the index number at which this particular match object starts. So basically in Python, repackage provides several methods to perform queries on an input string such as match, search, find all as we discussed in our lectures. Python offers two different primitive operations, the match and the search. As we already saw the search function, but the match method checks for a match only at the beginning of a string, while the search checks for a match anywhere in our string. Let me show you the match method. re.match finds skill in the text, so it returns a match object, says the skill is found at the very beginning of our text, and it is the first occurrence. This method checks only for a match, only at the beginning. So if a pattern was found in the beginning, it returns the object. But if the match is not found in the beginning, then it returns none. For example, if I search re.match .match data in my text, it returns none. So this is the basic difference between match and the search. The search method looks for the pattern in the entire string and returns the first occurrence of match if found. Otherwise, returns null. In order to use the search function, you need to have a pattern and a text. For example, if I have data as the word twice in my string, and if I run the code again, then it returns the first occurrence. Only that is this data. So this is how search and match works. Next, we have the find all module, which is used to search for all occurrences that matches a given pattern. So, in contrast to the search module, which only returns the first occurrence, it will iterate over all the lines of the file and will return all non-overlapping matches of a pattern in a single step. For example, consider this text again. I am using the find all method, and again I'm using the pattern data. Now if I run the code, it returns data twice. So basically it finds all the patterns from my particular string. We can use these methods in if else or loops to find patterns and extract values from larger text. Let me show you an example of suppose we power tech, light bound, working tree, and I want to find a pattern that belongs only to digit. I want to find only digits in my text. So I'm going to use re.searchPattern in text. It says that match is found, which is 3 at an index position 15. So in this way, you can check the difference. You know the regular expression patterns. Now you have to find only the word. You can use W here instead of D. W is used to find words, so it returns the first occurrence of a word, which is at 0 index, and the match is Python. Similarly, you will find all here match methods and play around with it. We can also provide a list of values and iterate over it using regular expression module to find a pattern. So let me show you an example of, let's say we have a list of vegetables and fruits. Now I want to iterate over it and want to find all those elements there to start with a letter C. So let me do this for you. This is the for loop which iterates over our list. And here we use the match method to find all those words starting from C in our list. Run the code and it returns capsicum, carrot, cabbage, and their index values. And we have two null values, pineapple and onions, as they do not start with C. Similarly, we can use search to find out and mix it with for and if else to extract meaningful values. Next, we have the split function, which is used to parse a long string. So, for example, I have a string which contains different years, such as 2000, 2009, 2010, and so on. Now I want to parse my string whenever it encounters a comma, so my pattern of my splitting is a comma. You can use any character or any word for splitting. Now I'm going to use result variable to store my result. I'm using split function here, providing list of values and split pattern. Now print the result. Okay, this is not what we expected. So I mistakenly used a pattern variable instead of pattern underscore split variable. Now run again. See, the values are separated once a comma is encountered. What if I want to get only two splits? Add 2 in the parameter list of split function. Now we get 2 splits and the remaining values. You can pass any number of splitting values. Also, if no pattern is found, then this method returns the original string. For example, if I set semicolon as split pattern, then same list gets printed. Next, we have substitute method. Now I want to match all the white spaces encountered in my string. To find all white spaces, use plus sign. Now set a replace variable to null. I want all spaces to be removed from my string. Now I call the re.sub method. It takes 3 arguments pattern, string to replace, and the original string. Now print the result. You see all white spaces are gone. You can try other regular expressions pattern and methods. Hi friends, coming to the most crucial and interesting topic of the course, Section 7, Exploratory Data Analysis. Real-world problems are translated into machine learning models for answers and predictions. This is achieved by passing data through a series of steps called data science process. Data science is an interdisciplinary field that allows you to extract knowledge from structured or unstructured data. Exploratory data analysis is the answer to what is going on here. It helps in understanding the datasets by summarizing their main characteristics in non-graphical form or visual representation. In this phase, we also explore data types and anomalies present in our dataset that we missed before. There is no one method or common methods in order to perform EDA. But usually EDA steps encompasses 8 steps from importing necessary data and libraries, along with preparation of data and cleaning, which includes dropping duplicates and removing missing values, finding outliers, data profiling, correlations among features to visualization. Up till now, we have learned how to acquire data, import libraries, prepare and clean datasets. Now, it's time to understand the nature of our data, what it really means. So let's move to our next lecture. Data is in the form of statistical collection of facts. But there are different types of statistical data. In this section, you will learn about it. Statistical data is mainly classified into 2 types, numerical and categorical data. Numerical data or quantitative data comprising numbers or numerical values to represent the data. This includes height, weight, and age of a person. It gives information about the quantities of a specific thing. It is further classified into discrete and continuous data. Discrete data are integers that cannot be subdivided into smaller parts, such as number of Facebook likes or votes cast in an election. Continuous data can be calculated. It has an infinite number of probable values that can be selected within a given specific range. Continuous data can be further categorized into a couple of types, interval and ratio. Interval scales are numeric scales in which we know both the order and the exact differences between the values. The classic example of an interval scale is the Celsius temperature, because the difference between each value is the same. Represents exact value between units, and they also have an absolute zero, which allows for a wide range of both statistical and inferential statistics. Ratio scales provide a wealth of possibilities when it comes to statistical analysis. These variables can be meaningful added, subtracted, multiplied, divided. Central tendency can be measured by mode, median, and mean. This also includes measures of dispersion, such as standard deviation and coefficient of variation, which can also be calculated from ratio scales. As the name suggests, data that can be divided into groups are called categorical data. Categorical data is also known as the qualitative data, describing the data that fits into the categories. Qualitative data are not numerical. The categorical information involves categorical variables that describe the features such as a person's gender, hometown, etc. Examples of the categorical data are birth date, favorite sport, school postcode. Here, the birth rate and school postcode hold the quantitative value, but it does not give numerical meaning. Nominal and ordinal are its subclassifications. Ordinal data variable is a type of data which follows a natural order. The significant feature of the nominal data is that the difference between the data values are not determined. This variable is mostly found in surveys, finance, economics, questionnaires, and so on. The ordinal data is commonly represented using a bar chart. Nominal, it cannot be ordered and measured, but sometimes the data can be qualitative and quantitative. Examples of nominal data are letters, symbols, words, gender, etc. The nominal data are examined using the grouping method. In this method, the data are grouped into categories and then the frequency or the percentage of the data can be calculated. These data are visually represented using the pie charts. In this topic, we're going to walk you through the concept of data profiling. Data profiling is the process of examining the data available for an existing information source. For example, a database or a file, and collecting statistics or informative summaries about the data. The whole purpose of these statistics may be to find out whether existing data can be easily used for other purposes. We perform data profiling to see the details through a large data set, and it's important to go for an exploratory data analysis. Understanding the data is the critical step in preparing the data to be used for analytics. As many experts will point out, the data preparation and transforming the data into a tidy format takes about 80% of the effort in any data analytics or data analysis project. It can be done in Python using a few lines of codes, but what actually it gives you is a complete descriptive statistics of the data set, such as the data type you are working on, central tendency of data values, length and shape of the data set. This also includes skewness and distribution, with occurrence of null values, presence of unique values, etc. Isn't it cool? Library to perform data profiling in Python is Pandas profiling import it from the command prompt. Guys, now it is time to perform data profiling in the Python environment. A considerable part of data science or machine learning job is data cleaning. In this lecture, we will discuss it. Often, when data is collected, it's messy. Data cleaning means the process of identifying the incorrect, incomplete, inaccurate, irrelevant, or missing part of the data, and then modifying, replacing, or deleting them according to its necessity. Data cleaning is considered a foundational element of basic data science. What is data untidy? Often the dataset contains missing values and incorrect model, and analysis will be done if not tackled properly. Common data problems are data entry errors, missing values, redundant white space, impossible values, outliers, inconsistent column names, different units of measurement. Also, data having outliers means data that is not a true representation of the feature. The column's values are supposed to count occurrences of good and bad in the column. It can be possible that the data entry operator did a type error, such as instead of typing good, he typed goad with a U. As you can see, we get two more results, goad and bass, which is a result of data entry errors. The data values may have been leading and trailing white spaces, which later on create issues in matching. Python uses string functions to remove it. There is possibility of incorrect or impossible value too much as 150 in age column. One of the biggest challenges in data cleaning is the identification and treatment of outliers. Values of the dataset that fall far from the central point, the median, are called outliers. There are different ways to find outliers using Python in your dataset. Column names of the features may have inconsistent names or different casings. Last but not the least, the units of measurement may be different. For example, in the weight column, here we have pounds and kilograms both. The difference between a good and an average analysis is often its ability to clean data. Therefore, it is very important to treat and clean the dataset properly. Hi friends, it's time to dig deeper to know more about missing values and ways to remove it in the best possible way. Real-world data often has missing values. Data can have missing values for a number of reasons, such as observations that were not recorded and data corruption. Handling missing data is important as many machine learning algorithms do not support data with missing values. Training a model with a data set that has a lot of missing values can dramatically impact the machine learning model's quality. Multiple reasons of missing data values are data entry error, data corruption, not recorded, optional data. Here is an example of missing values in a data set. There are various ways to replace missing data, such as deleting rows. This method is commonly used to handle the null values. Here, we either delete a particular row if it has a null value for a particular feature, and a particular column if it has more than 70 to 75% of missing values. This method is advised only when there are enough samples in the dataset. One has to make sure that after we have deleted the data, there is no addition of bias. One thing to remember is that removing the data will lead to loss of information, which will not give the expected results while predicting the output. Number 2, replacing with mean, median, and mod. This strategy can be applied on a feature which has numeric data like the age of a person or the ticket fare. We can calculate the mean, median, or mod of the feature and replace it with the missing values. Number 3, assigning a unique category. A categorical feature will have a definite number of possibilities, such as gender, for example. Since they have a definite number of classes, we can assign another class for the missing values. Here, the features cabin and embarked have missing values which can be replaced with a new category, say U for unknown. This strategy will add more information into the dataset which will result in the change of variance. Number 4. Predicting the missing values. Using the features which do not have missing values, we can predict the nulls with the help of a machine learning algorithm. This method may result in better accuracy unless a missing value is expected to have a very high variance. Using algorithms which support missing values. KNN is a machine learning algorithm which works on the principle of distance measure. This algorithm can be used when there are nulls present in the dataset. While the algorithm is applied, KNN considers the missing values by taking the majority of the k nearest values. In this particular dataset, taking into account the person's age, sex, class, etc., we will assume that people having same data from the above mentioned features will have the same kind of fare. Now it is time to replace missing values in our dataset. Exploratory data analysis (EDA) is an important pillar of data science, an important step required to complete every project regardless of the type of data you are working with. Exploratory analysis gives us a sense of what additional work should be performed to quantify and extract insights from our data. In this lesson, we will be performing exploratory data analysis on Titanic dataset. The Titanic was a tragic event in 1912 in which a British passenger ship sank with more than 1,500 passengers on board in the Atlantic Ocean. Data of many passengers, both those who survived and those who did not, has been compiled over the years and published. With today's new technology, answering questions through data analysis is now easier than ever. Now, the big question is, what factors made people more likely to survive the sinking of the Titanic? Is it gender or social class or a particular age bracket? We can look at the contents of the data set to answer them after proper steps. After looking at the contents of the data set, I thought it would be interesting to look at the following questions. Which gender had a better chance of survival? Which social class had a better chance of survival? Which age group had a better chance of survival? Let's start with importing required libraries. Now I will read the Titanic dataset using pandas read_cv method and explore the first 5 rows of the dataset using the head method. Now print last 5 rows of the dataset using tail method. Print number of observations and features using shape method. Here we got 891 rows and 12 columns. We can also list down the names of columns using columns property of data frame. Output cell shows the name of columns present in our dataset. Now let's get some info on data types in the dataset using pandas.info method. It will give us a concise summary of a data frame. From the output, we see that age, cabin, and embarked have missing values. Conventionally, a feature missing more than 5 to 10% of its values is considered to be missing data, and so needs to be dealt with. On the other hand, all instances that have missing values for all features should be eliminated as they do not provide any information to the model and on the contrary may end up introducing bias. When dealing with a feature with a high absence rate, it is recommended to either eliminate it or fill it with values as discussed earlier. Now let's print statistical analysis of the dataset before data imputation and standardization. Type data_df.describe. For numeric D types, it will include count, mean, std, min, max, lower, 50, and upper percentiles. From the table, we can see that the mean of survived column is 0.38. But since this is not a complete data set, we cannot conclude on that. Count for the age column is 714. It means the data set has some missing values. I will have to clean up the data before I start exploring. When this method is applied to a series of strings, it returns a different output, which is shown here. It returns top, unique, and frequency of value in a particular column. There are 147 unique cabins in the ship out of 204, 2 gender values, and all unique names while embarked. Let's find out unique values present in sex and embark type data_df.sex.unique and convert it to a list. As expected, male and female are unique values present in gender. Now, for embarked, do the same. It shows 3 unique values, S, C, and Q, along with the nan. We have seen that there are some missing values in age, cabin, and embarked columns. Let me explore age further to get a better understanding. First, display the top 10 values of age from the dataset. As you can see, the feature has nan, not a number of values, which represents missing values. Count the number of nan values to determine how to handle them. Use the isNull function to find the nan values and use the sum function to sum them all. Here we have 177 missing values in the age column. Further exploration using group by reveals that 53 missing values belong to females and the rest belong to males. Overall mean of age is around 29.69, but instead of replacing missing values with this value, we first find the mean of age according to the P class and sex. First, determine mean age based on sex and P class. I'll not use cabin, which is the most missing, and will ignore it. There are some columns which are not required in my analysis, so I will drop them later, such as passenger ID, name, ticket, cabin. For the missing, ages, and embarked, I will perform missing values imputation. Before trying to determine the characteristics of a passenger that would make them more likely to survive, the number of survivors in the sample should be compared to the actual number of survivors. Today, we will discuss outliers and how to remove them in detail. In simple words, any data point that doesn't belong to a certain sample or population is an outlier. It is of very much importance because if not taken properly care, it can result in skewed measurements. A data point that lies outside the overall distribution of the dataset. We see here in our example that there is a set of 9 values ranging from 18 to 30, but a very large value, 4300, appears in it. This value is not part of our dataset, but from some source of uncertainty it contained in our set. This value can have a very bad impact over the statistical analysis of our data. Let's see, where do these values come from? What effects do they have, and how can we eliminate them? There can be many reasons for outliers in our dataset. Some of common ones are data entry errors. A person, while entering the data for a certain experiment, might feed in the wrong values, introducing an outlier. Or it can be caused due to the measurement error. Say you have a parameter measuring sensor. To be more specific, let's say we have a temperature sensor, which happens to be installed in our room. The device measures the temperature and sends the value to the database, which stores the values. Due to the sensor error or some randomness exposed to the sensor, it might cause wrong value feeding to our dataset. These can be a source for outliers in our dataset. As you can see, dataset with outliers has significantly different mean and standard deviation. In the first scenario, we will say that average is 5.45, but with the outlier average sourced to 30. This would change the estimate completely. Until now, we have seen the outlier impact with smaller dataset. But how can we observe for the existence of an outlier on a larger dataset? For that, we use some statistical tools for visually analyzing such existence. Few detection techniques involve boxplot, histogram, and scatterplot. Let's have a quick view for each of them. When dealing with outliers, most of the ways to deal with them are similar to the methods used for missing values, like deleting observations, transforming them, bringing them, treating them as a separate group, imputing values, and other statistical methods. As we are now familiar with data problems and cleaning steps, it's time to perform exploratory data analysis over a dataset and get familiarized with the EDA process. We will be discussing Titanic dataset here. The dataset contains 12 features. In the dataset, there are 891 instances of rows of data. Let's explore the data randomly. Clean them if necessary and see if there are any missing values or outliers. Okay, so let's find outliers in our data set. So as you can see that in age and in fair, we have a large number of standard deviation. That means in the age and fair columns, we can expect outliers. So before finding outliers in age group, first I'm going to plot the histogram to visualize the distribution. Type the code and pass 50 bins to it. See, it is a normal distribution, and you can see that majority of the passengers are young. That is in the age group of 20s to 30s. So let's find out the outlier in this age column using boxplot. Boxplot is used to visualize outliers in our dataset. So we can see that there is a spread of values in it to find exactly how much the outlier is in our dataset. Majority of our data lies in 20 to 30 age groups. We can use the z-score. Let me show you in a snippet here. I have imported a library z-score from scrippy.states, and then I created two columns which store z-scores and of values, and the other one is whether the value is an outlier or not. I just applied a lambda function over the calculated z-score, and if the value is greater than equals to 2.5 or less than equals to negative 2.5, then it is an outlier. Next, I printed those observations that are outliers. So you can see that these values are the outliers. Coming to statistical methods. There are different parameters to have an overview of what your data is telling you. In this lesson, you will learn some of the statistical methods used in EDA. Once the data set is loaded, you can read the top and last observations of your large data set to have information about the dataset. Head function is used to view the top 5 rows of data, and the tail method is used to view the last 5. We see that there are 12 columns in our dataset, each of them giving some useful information. We can also say that these 12 columns show different features of the data. Passenger ID. This is the passenger number for each of them in our dataset, starting from 1 to 891. Survived. This column represents the information for the survival of passengers, where 0 is equal to not survived or dead, 1 is equal to survived or alive. P class. This is the passenger's ticket class, where 1 is equal to first, 2 is equal to second, and 3 is equal to third. Sex. This contains the gender of the passenger. Age. These are the age numbers of each passengers. SIB SP. This value represents any sibling or spouse of the passenger if present, in which the number shows the total count for the same. Parch. This value represents any parents or children of the passenger if present, in which the number shows the total count for the same. Ticket. This is the ticket number for each passenger. Fare. This is the fare amount value that each passenger have paid to board. Cabin. Cabin number for each passenger. Embark. This shows where the passenger was embarked from port of boarding, where C is equal to Cherbourg, Q is equal to Queenshow, S is equal to Southampton. To get the dimensions of the dataset, use shape property. As you can see, we get the total number of rows 891 and 12 columns as I told you earlier. And the columns property display all feature names already familiar to you. Use the info method to output some general information about the data frame. Int 64, float 64, and object are the data types of our features. With this same method, we can easily see if there are any missing values. We have missing values in age, cabin, and embarked columns. To find the central tendency, qualities, and range, use describe method. The result shows the statistics of our numerical data. It is important to note that the mean age of passengers is around 30 years and the youngest passenger is less than a year old. Note that this analysis is done without doing any missing value imputation. We can also analyze non-numerical features if we type include parameter in the describe method. The results show that we have 2 gender, 681 tickets, and bought also 147 unique cabins and 3 places to embark the journey. There is another way to find stats of categorical features. Value underscore counts method. This method reveals how many passengers survived the disaster and how many died. Total 549 out of 891 died and 342 survived. The results can be normalized if it is set to true. Let us perform these statistical analysis in the lab. In this lesson, we are going to learn about retrieving and selecting a subset of data from a data frame using indexing. A data frame can be indexed in different ways. To get a single column, we can use a square bracket construction in which we can pass a column name. In this example, we want to find out the average of survived passengers, so we call dataframe data underscore df and pass column name survived to it. Next is Boolean indexing. That is, we pass some logical condition that is gonna be checked for each element of the provided column. So In our case, what are the average values of numerical features for surviving passengers? This is the result when we answer our query. It returns mean values of all numerical features belonging to surviving passengers. Indexing can be done using lock and ilock methods. The lock method is used for indexing by name, while ilock is used for indexing by number. In the first case below, we say, give us the values of the rows with index from 0 to 5 inclusive, and columns labeled from pre-class to age code inclusive. In the second case, we say, give us the values of the first 5 rows and the first 4 columns. As in a typical Python slice, the maximum value is not included, but index number starts from 0. You can also retrieve values by applying functions to cells, columns, and rows. To apply functions to each column, use apply method. Here, an example, we applied it on column categorical var to find out the unique number of values in each of it. To apply method can also be used to apply a function to each row. To do this, specify axis equals to 1. Today, we will discuss what data normalization is and its importance in EDA. It is simply the process of rescaling one or more attributes to the range of 0 to 1. This technique is used to make data or models less sensitive to the scale of features, but without losing information, which means the weightage of a particular value doesn't change. The graph on the left-hand side shows the original data, whereas on the right-hand side, we have a plot of normalized values ranging from 0 to 1. Normalization makes the features more consistent with each other. First, we calculated the normal count of surviving and non-surviving passengers and got 549 as deceased and 342 as lucky survivors. Later, we normalized our count, and in result, we got values in between 0 and 1. This is how we can perform NP normalization. Or Python provides the preprocessing library, which contains the normalize function to normalize the data. It takes an array as an input and normalizes its values between 0 and 1. It then returns an output array with the same dimensions as the input. In our data set, we have created a column of titles and next normalized it. Let us perform this in Jupyter. In this section, we discuss how to correlate features and perform binning of categorical features. Data binning, which is also known as bucketing or discretization, is a technique used in data processing and statistics. Binning can be used, for example, if there are more possible data points than observed data points. An example is to bin the body heights or age of people into intervals or category. It is a form of quantization. But bins do not necessarily have to be numerical. They can be categorical values of any kind, like Mr., Mrs., Miss, and so on. Pandas cut function is used to segregate array elements into separate bins. The cut function works only on one-dimensional array-like objects. The cut function is useful when we have a large number of scalar data and we want to perform some statistical analysis on it. For example, let's say we have an array of numbers between 0 and 90. We want to divide them into multiple bins and add labels such as infant, tens, 20s, and so on. We can easily perform this using the pandas cut function. Correlation quantifies the association between variables or features of a dataset. It is one of the most common and obviously useful parts of analyzing data. What moves with what, which variables are dependent and which are independent. For example, you might be interested in understanding the following: how the gender of passengers is correlated to their survival, whether there's a relationship between age and survival. There are several statistics that you can use to quantify correlation. For example, persons are, Spearman's row, candles thaw. Correlation can be visualized easily using heat maps in Python. The heat map tells us the strength of the correlation between survived and each of the other columns. Based on our EDA, it seems like age, class, and sex might be the good predictors in our model. Port of embarkation may be good, but it seems like most of the passengers got on at Southampton, so we're not sure if this will have a big impact. Now it's time to find correlation among features of our dataset. Type the code df.core function and it displays the correlation among our dataset features. And now we can, divide these continuous numerical values into bins, or you can say groups using pandas cut function. The cut function is used to segregate elements into separate bins. The function works on one-dimensional objects and it's useful. And we have a large number of scalar data, and we go on to perform some statistical analysis on it. So, for example, let me show you the column analysis, and you can see we have 891 observations. We have a minimum value of 0.4 to suggest that the passengers has an age of less than 1, means the passengers is an infant, and then the maximum age of 80. So let's divide these into bins. I'm going to create our new column for age underscore bins. And now I'm going to use the pandas cut function. Here, I'm going to provide my column, which acts as a one-dimensional array. Now, it's time to set bins. So I'm going to pass values from 0 till 90. Next, I'm going to provide labels for my bins. And basically, you have to provide one less label than your groups, as you are creating ranges of 0 till 10, 10 to 20, and so on. Now groups are set. Run your code and explore it using the head method. Now we have a new column, age underscore bins, in our data frame. And now let me show you the value counts of each age ranges. Type the code and run it. So there are 64 infants that are below the age of 10. Between 10 to 20, there were 150 passengers. There are no passengers above the age of 80. Majority of the passengers are middle-aged. Now, let me show you the crosstab results, which also gives you a good indication on the survivor in these age groups. The output clearly suggests that infants had a better survival chance, and then around 33% and 44% belonging to the 20s and 30s age group had a good chance of survival. So this is all about binning. Now it's time to find correlation on features of our dataset. Type the code df.core function and it displays the correlation among our dataset features. The value of correlation lies in the range of -1 to +1 value. Either positive or negative greater than 0.5 suggests a strong correlation. So you can see that from the above table, from this particular table, is that fare and survival have a significant negative correlation. Also, passengers class and survive seem to have a correlation. Also, we can use a heat map to visualize the coordination result. I'm using Seaborn for it. Type sns.heatmap and pass df.core, set annotation to true, and run the code. And you can see here is the heat map. We can see that fare and passenger class seem to have a significant correlation with the survival probability. This and also the fare has a good correlation with the passenger class, which means greater the fare, higher the passenger class. But this visualization or this correlation results does not make other features useless. Subpopulation in these features can be correlated with survival. So to estimate this, we need to explore these features in the upcoming lectures. You will learn how to group data and to gain insights from it. Till then, happy coding! Today, we will once again refresh our concept of grouping data. We can arrange our data into groups based on some conditions so that it may be more easy to analyze things. In Python, we have group by function which returns object for values from one column. First, the group by method divides the grouping columns by their values. They combine a new index in the resulting data frame. Then, columns of interest are selected, columns to show. If columns to show is not included, all non-group by clauses will be included. Finally, one or several functions are applied to the obtained groups per selected columns. Here, we are grouping passengers according to gender and ticket class. The result reveals that there are few females belonging to the middle class and a very handsome number of passengers belong to lower class and were male. Similarly, you can group the data with different variations to see interesting results. EDA is a crucial step to take before diving into machine learning or statistical modeling because it provides the context needed to develop an appropriate model for the problem at hand and to correctly interpret its results. It explores the data in such a way that interesting features and relationships between features will become more clear. In EDA, you typically explore and compare many different variables with a variety of techniques to search and find systematic patterns. Sometimes it's useful to group similar data items together as they give meaningful insights and new dimensions. I'm going to use the group. Suppose I wish to know the number of passengers in each category, so I will use the group by method and pass the column name P class, that is passenger class, to it. Next, count the size of the passengers. I am using the size method along with group by. Results show that the majority of the passengers belong to the lower class. Next, I want to know the count of gender in each passenger class. This time, I can use group by method with two values and a list, sex and passenger class. So we can see that from this data, we can clearly see that the majority of the passengers were male and belong to the lower class. Now I'm going to add a new column survival to store survived status as string for better visualization. Here I created the survival column, and if the passenger has survived the event, then its value is set to survive. Otherwise, if it is 0, then the value would be set to not survive. Run the code. Now, check the top 5 rows and you can see the survival column for values: not survived and survived. Now I'm going to, group my data with survival and passenger class. You can see that 372 passengers in the lower class were drawn in this tragic event. Majority of the passengers belonging to the first class survived, although the total count of the passengers in this particular class is lower than the other categories. So we can see the survival rate of the first class passengers was higher. We can also use the group by method to plot graphs. I'm using the group method to visualize the age versus survival trend using Matplotlib library. Next, group the data using the age_bin column to find the count of survived passengers in particular age groups. We can also set the title and form size of your graph. Set legend equals to true. Okay, so it says okay by mistake. I forgot to put by here. So you can see the survival trend here. So the majority of the survivors belong to this age group. You can also summarize and tabulate data using group by function. This is how we can do grouping in Python. Okay, let's see. The survival rate type dog. So why don't you? I chose 342 passengers who survived that event. Now you can normalize this using the argument normalize equals to true normalized equals true. And you can see, no, what I'm going to do, I'm going to create a new column or title, which I'm going to expect from the names of the passengers to see how many meals we have, how many number of females that mattered in single we have, and how many officers do we have in our procedure list. So what I'm going to do here, I'm creating our new column title, and I'm going to use I'm going to apply the function on any column using apply lambda expression name, and then splitting the name from my list. You think the loss value or for a false value and prepping for that, you can only get the particular value out of it. Okay, so it says we have a syntax center basically. I forgot to add it. Now we have a title column. Check it using the head function. So now I know you can see we have the titles now. What I'm going to do, I'm going to normalize the titles. So what is the reason to normalize the title? Why do we need it? Because if I use the value column on my title column, you can see that we have a very large amount of values in it. See, we have 5, 1, 7, 7 doctors, 6, rest 2, colonels, 2 majors, and so on. So what I'm going to do basically, I'm going to, or normalize these titles into Mrs. Royalty Officers and so on. So we'll stop for wired, our additional, you have normalized title, and which captain, colonel, major belongs to officers. Similarly, the doctor is also an officer there. Sir and Don is royalties, the counters and donors or charities, whereas others, some are Mrs., some are single, and some are Mr. So now I'm going to map this normalized starter to my already present column title. So let's print the value of count of my normalized titles. Okay, so we don't have the title column and 517. Miss Torres wanted 4 minutes. 127, Mrs. Masters, 18 officers, and 5 royalty instead of search dispersed values. Now I'm going to use Seaborn for visualization of the value count. So it is used to visualize the count of a particular column here. I'm going to use the title column. You can see the visualization here. The majority of passengers are male. Now let's see the survival reach according to titles. So what I'm going to do is I'm going to use a bar plot and for white X value as title Y as survived. Next, providing the data set and the data, now I run the food output. Okay, you can see that although the majority of the passengers are male, their survival rate is very low. Our work, the females, its chances of survival for females are very high. So people with the title and mistress survive less than people with any of the titles with the survival rate higher than 70 are those that correspond to the female. Let's remove the irrelevant features from our dataset type, the drop, and provide the name of the columns, add list here. I'm dropping for singularity as it is useless as it is to have too many missing values tickets. And since we have extracted the title column from the names, therefore we don't have much information in the name column. No? Okay. And place equals 2, so now these calls are dropped from our table. To confirm it, type d.had. And now we don't have any game and ticket, any name in our data frame. Since we have done the implementation, now we can check a name tag off our dataset or pneumatic and features. See, the mean age is now going to say 29.69 as earlier, first 32.2, and now similarly you can find the statistical analysis of object type or categorical type as we did earlier. I will leave it up to you. Hello friends, and welcome to section 8 of the course, Data Visualization. Previously, we learned how to load data and perform exploratory data analysis. Now it's time to look deep into visualizing data into different graph formats. Data visualizations make big and small data easier for the human brain to understand, and also makes it easier to detect patterns, trends, and outliers in groups of data. Data visualization tools provide an accessible way to see and understand trends, outliers, and patterns in data that may not be exposed otherwise. One of the key skills of a data scientist is the ability to tell a compelling story, visualizing data and findings in an approachable and stimulating way. As we all know, a picture is worth 1,000 words. We can use different visual elements like charts, graphs, maps, infographics, etc. We have many tools and techniques to visualize our data, such as Tableau, which is a business intelligence tool that aids people in visualizing and understanding their data. It is widely used in the field of business intelligence. It allows you to design interactive graphs and charts in the shape of dashboards and worksheets to obtain business vision. Data visualizations using Python libraries to make charts, graphs, and maps, and we are going to do visualization using Python. Dundas VI, very famous visualization tool. Its other visualization features include rich scorecards, smart tables, numerous chart types, gauge, maps, tree map, data labels, sparkline, indicators, diagrams, and relationships. Infogram, which is a web-based data visualization and infographics tool that permits users to create and share digital charts, infographics, and maps. Google Charts is a powerful, easy to use, and an interactive data visualization tool for browsers and mobile devices. It has a rich gallery of charts and allows you to customize as per your needs. It comes handy for small data. Excel visualizations can be used too for charts and graphs. If you want to visualize a lot of data and analysis, where can you go? Which visualization libraries should you use in Python? What does the Python visualization landscape look like? These are the questions that pop into the mind once we start. The Python landscape is ever-changing, and sometimes libraries will pop up and slowly die. Python offers multiple great graphing libraries that come packed with lots of different features. No matter if you want to create interactive, live, or highly customized plots, Python has an excellent library for you. Few popular plotting libraries are Matplotlib, which is low-level and provides lots of freedom. Pandas visualization, easy-to-use interface, and built on Matplotlib. Seaborn, high-level interface, great default styles. ggplot, based on R's ggplot2, uses grammar of graphics. Plotly can create interactive plots. In this section, we will learn how to create basic plots using Matplotlib and Seaborn. Visualizations are divided into two main groups. Number one, SciVis, and number two, InfoWise. SciVis is typically applied to data with an intrinsic spatial layout. For example, a flow simulation in 3D space, whereas InfoWise deals with data that has no predefined spatialization, for example, graphs of web links. Similarly, SciVise's data tends to be continuous, whereas InfoWise's data tends to be discrete in nature. We will be dealing with InfoWise's group of visualizations. In the next lecture, we will be discussing Matplotlib and how to visualize our dataset using it. Today, we will be discussing Matplotlib and its features. It happens to be the most popular and older Python plotting library. Matplotlib is used for creating static and animated visualizations, specifically good for creating basic graphs like line charts, bar charts, histograms, and many more. It is a Python 2D plotting library and works well with any operating system. It is a low-level library with a simple interface, which offers loads of freedom at the cost of having to write more code. Matplotlib documentation is also available on the internet, www.matplotlib.org, from where you can get any help related to function, definitions, usage, and parameters. To install Matplotlib, pip command can be used. Open command prompt and type pip install matplotlib. To use this library in your Python program, type import matplotlib.py pyplot and give any alias, say MPL, as you wish. Matplotlib is specifically good for creating basic graphs like line charts, bar charts, scatter plot, stream plot, histograms, pie charts, log plots, and many more. The two most common functions are plot and show. You can pass a single list or any array to it, and it assumes it to be a vector of y values. To pass both x and y coordinates, supply the x and y data both. Next up is show and is called to display the plot. Let me know show is an example of them in Jupyter. Not only we can display a plot, but also it can be saved to our local machine using method savefig. Just provide the name of the figure along with the extension PNG, and it will be saved in the same folder as the script. Supported formats to save the figure are EMF, EPD, PDF, PNG, PS, RAW, RGBA, SVG, and SVGZ. If no extension is specified, PNG format will be used automatically. Figure aesthetics can also be set by changing the color and line styles of the graph plot after providing data to the plot function. Color used are blue, green, red, black, and cyan, and can be specified using their abbreviations such as B for blue. Line styles can be solid, dashed, dash dot, and dotted lines. You can also use circles, plus symbols, crosses, and diamond shapes where line styles are not applicable. For a complete list of line styles and format strings, follow the link. Look under matplotlib.pyplot.plot. Let me show this to you. Title, text, and labels can also be set using xlabel, ylabel, title, and text method. In simple cases, all but text method just takes a string argument. Text method needs at least 3 arguments, x and y coordinates as per the axes, and a string. All take optional keyword arguments or directories to specify the phone properties. They return instances of class text. This is a simple example to draw a line chart with some text, title, and labels. You can try it at your own end. Here are some basic properties of the text method in Matplotlib. You can adjust the transparency of the graph using alpha property whose value ranges from 0 to 1. Next up, we have color property, font, and alignment properties. It's time to discuss a legend in detail. A legend is a box which appears by default in upper right along with associating labels with lines. In this example, we plot 2 arrays with red and blue colors having different line styles and uses legend method as shown. We have different types of charts to visualize our data. Few of them are line chart, bar chart, histogram, scatter plot, and pie chart. Line graphs are helpful for visualizing how a variable changes over time. Some possible data that would be displayed with a line graph. Average prices of petrol over the past few months, weight of an individual over the past couple of months, average temperature along a line of longitude over different latitudes. Here is an example of a line graph showing the values of 2 arrays. We can also have multiple line plots displayed on the same set of axes. This can be very useful if we want to compare 2 datasets with the same scale and axis categories. Matplotlib will automatically place the 2 lines on the same axes and give them different colors if you call plt.plot twice. Here we are showing a set of expenses day-wise. Let me show you the same code in the Jupyter environment. Sometimes we want to display 2 lines side by side rather than the same set of x and y axes. When we have multiple axes in the same picture, we call each set of the axes a subplot. The picture or object that contains all of the subplots is called a figure. We can create subplots using method subplot. For labeled non-time series data, you may wish to produce a bar plot or to make comparisons. Basically, a bar chart presents categorical data with rectangular bars with heights or lengths, proportional to the values that they present. The bars can be plotted vertically or horizontally. It conveys relational information quickly as the bars display the quantity for a particular category. Function bar creates a bar chart with left and height as required arguments. Left is used to specify sequence of x coordinates, and height is used to represent the value of category or item. There are some optional arguments as well as such width, color, orientation, cap size, log, etc. Here I am displaying student marks in the form of bars. The method requires two arguments, x values and y values. For x values, I have used len method that calculates the total number of elements present in the list students underscore marks. For y values, student marks are passed as a list. We can use a bar chart to compare two sets of data with the same types of axes values. To do this, we plot two sets of bars next to each other so that the values of each category can be compared. For example, here is a chart with side-by-side bars for the populations of the United States and China over the age of 65 in percentages. Histogram is used to plot the frequency of score occurrences in a continuous data set that has been divided into classes called bins. Bar charts, on the other hand, have been discussed earlier. They can be used for a great deal of other types of variables, including ordinal and nominal data sets. Scatter plots are used to plot data points on a horizontal and vertical axes in the attempt to show how much one variable is affected by another, or to show the intensity of data points in a particular area. Let me show you how to perform visualization using histogram and scatter plots. When we are trying to work out the composition of something or we have categorical data, then using a pie chart would work really well, as each slice can represent a different category. Pie charts are helpful for displaying data like different ethnicities that make up a school district, different macronutrients, carbohydrates, fats, and proteins that make up a meal, different responses to an online poll. We can make a pie chart with the method plt.pie. Here is a simple pie chart to represent the budget data. This is an excellent visualization to quickly look at the budget share of each department. You can add legends and labels to it. Analysis and modeling depends heavily on the patterns identified in the dataset during the data visualization phase. Here, I will be discussing the most common plots of the Matplotlib library. Matplotlib is a multi-platform data visualization library built on NumPy arrays. You can draw up all sorts of charts and visualizations using Matplotlib. Matplotlib is the whole package. PyLab is a module in Matplotlib that gets installed alongside Matplotlib, and matplotlib.pyplot is a module in Matplotlib. And pyplot means that figures and axes are implicitly and automatically created to achieve the desired plot. For example, calling plot from pyplot will automatically create the necessary figure and axes to achieve the desired plot. Setting a title will then automatically set that title to the current axis object. Pylab combines the pyplot functionality for plotting with the numpy functionality for mathematics and for working with arrays in a single namespace. The pyplot interface is generally preferred for non-interactive plotting, that is scripting. The Pylab interface is convenient for interactive calculations and plotting, as it minimizes typing. First, import the necessary libraries for visualization. I'm going to import matplotlib.pyplot with aliasing plt, and secondly importing pylab. Run the code and these libraries are imported in the application. Let's explore pylab first. Here is the code snippet used to plot a line chart. These are the data values, and we are using xlabel and ylabel methods as discussed in the lectures to display labels. We have title method to display the plot title. And lastly, setting text properties. Now run the code and display the line chart. Okay, I just forgot the quotation mark in the text method. Again, running it after correction. This is our line chart with time on x-axis and vols on y-axis. We can add a legend also. For this, I am creating a multiple line chart on the same plot. Here is the code snippet having two sets of values. First is the same 1, 2, and 3, and I want it to be read next as a list of numbers 0, 1, and 2, having green color and in dashed format. Next, in legend method, I pass the data lines and text first and second to be displayed as legend values. Run it. The blue one represents first list of numbers and red represents second list. So this is how visualization can be done using Pylab. Currently, the use of Pylab is restricted and not recommended for visualizations. So moving to Matplotlib API. Let's discuss different types of charts available in Matplotlib API. First is a line chart. A line chart or line graph is a type of chart which displays information as a series of data points called markers connected by straight line segments. It helps in visualizing relationship among variables and to show trends. Let me show you an example of it. This is the code snippet. Use the plot method of matplotlib and pass x and y values to it. The show method is used to display the plot. The output shows a line chart showing continuous values. Also, we can plot multiple lines on a single chart. This is the code snippet. We have two sets of x and y values. And we are using title, which says two or more plot with suitable legends. In the end, use show method to display the plot, run the code, and see the output plot. You can plot more than two lines as well. Pyplot.subplots create a figure and a grid of subplots with a single call, while providing reasonable control over how the individuals plot. First, let me import NumPy module. These are x and y points. The objective is to draw a sine curve as we did in the section 6. Subplots and arguments returns a single figure and a single axis. This is actually the simplest and recommended way of creating a single figure and axes. Pass x and y values to the plot method and set title. So this is a sine curve. Now use the same method subplots to generate vertically stacked up subplots. The first two optional arguments of methods define the number of rows and columns of the subplot grid. Here I pass 2 only as an argument, which means 2 rows and 1 column. When stacking in one direction only, the returned axis is a 1D NumPy array containing the list of created axes. Here, we get two vertically stacked subplots. We can also create horizontal subplots. To get side-by-side subplots, pass parameters 1, 2 for one row and 2 columns. This is going to be horizontally stacked subplots. How about doing comparisons? We can generate bar charts for it. Bar charts are used to compare different categories. Here is the code snippet which contains a list of student marks. The bar method takes two parameters and passes your list in the y-axis. The x-axis will take the range of length of values in it. Next, show your plot. As you can see, you can clearly identify the test in which the students got the lowest and highest marks visually. That is, the student got lowest marks in fifth test and highest in last one. So this is very useful for comparing values. You can also give different styles to the chart, such as grid, line styles, font color, etc. Let me show you a code snippet which tells you how to do styling. First, I created a NumPy array and later converted it into a data frame and gave column names too. Later, I turned on the major and minor grids both using grid method, but giving different colors and line style to each type of grid. Now run it. So let me import it now and rerun it. We get a plot having major grid is in green color and minor grid in black. Also, we have a group of values for different indices. At any index, we can clearly see which column has a greater value than others. This example can be used to map performance of different employees monthly to find the best employee. Let us create a comparison chart of deaths due to COVID-19 in some countries to find the highest and lowest death count. This code snippet has a list of countries and the number of deaths today. Pass values to bar method and set color parameter to display bars in different colors. For more type of colors, check the official documentation of Matplotlib API. The death rate, or you can say count, is very high in the USA on a particular day. We can also plot horizontal bar charts. For this, I'm going to use bar method. Rest is the same as we did above. Just set the align and alpha property for styling. Moving on to the pie chart. Pie chart is used when we want to display the share of each component in a whole. This is the miscellaneous budget of different departments for a month. So the best visualization can be done using pie chart. Simply pass your data to the pie method. Now display it using show method. You can also perform annotation on it. Now I have added a list of department names and set annotation in percentage. The rest of the code is almost similar, but I used some formatting methods too. So you can see that faculty has the most budget amount. We can also explode a chunk out of it using explode property. As all the values are 0 in explode tuple except for the second one, you can, in the output that is the second component, faculty is sliced out of the pie chart. Now, let me do some visualizations by importing a dataset. First, import the famous iris dataset. Print the top 5 rows of it using head method. Now, I'm going to generate a scatter plot of the features sepal length against sepal width. You can see the density of data points through it. But right now, it is not very informative. Let me scatter the data points in different colors based on class values. Now, you can see we can clearly distinguish Setosa from the rest. This is how we can interpret results from visualizations. Hope you like it. In the last lecture of this section, we're going to explore data visualization using Seaborn. The creator of Seaborn, Michael Wascom, said if Matplotlib tries to make easy things easy and hard things possible, Seaborn tries to make a well-defined set of hard things easy too. When we are working with data frames, Seaborn performs exceptionally well. Seaborn is built on the top of Matplotlib. Seaborn supports complex visualizations of data by allowing comparisons between multiple variables. It supports multi-plot grids. It provides univariate and bivariate visualizations to compare between subsets of data. Color palettes are also available that makes visualization easy to understand. Ease the plotting of linear regression. In order to start with Seaborn, we need to install and import Seaborn library into the Python environment by using the command pip install Seaborn. To import Python type, import Seaborn as SNS. Seaborn line plots depict the relationship between continuous as well as categorical values in a continuous data plot format. You can create multiple Seaborn line plots very easily using Seaborn library. Three different ways can be used to display multiple line plots. First is by setting the hue parameter. The parameter hue can be used to group the different variables of the dataset and would help depict the relationship between the x and the y-axis data columns, with the column passed as a value to the parameter. Second is using the style parameter. We can set the style parameter to a value that we would like to display along with the x and the y axes, and also specify different line structures, dash, dots, markers, etc. We can even use the size parameter of Seaborn line plot function to represent the multi-data variable relationships with the varying size of line to be plotted. So it acts as a grouping variable with different size according to the magnitude of the data. If you are calculating a mean and would prefer to use standard deviation for your error bars, you can pass in the keyword argument ci is equal to sd to sns dot barplot, which will represent one standard deviation. For example, consider a hospital survey data. The mean satisfaction seems to depend on gender, but it might also depend on another column, age range. We can compare both gender and response factors at once by using the keyword hue. The hue parameter adds a nested categorical variable to the plot. This is the output of the examples discussed in the last slide. KDE stands for Kernel Density Estimator. A KDE plot gives us a sense of a univariable as a curve. A univariate data set only has one variable. KDE plots are preferable to histograms because depending on how you group the data into bins and the width of the bins, you can draw wildly different conclusions about the shape of the data. Using a KDE plot can mitigate these issues because they smooth the datasets, allow us to generalize over the shape of our data. To plot a KDE in Seaborn, we use the method sns.kdeplot. A KDE plot takes data and shades as arguments. Let's examine the KDE plots of our three datasets. Dataset 1 is skewed left, dataset 2 is normally distributed, dataset 3 is bimodal. It has two peaks. The box plot, which is also known as a box and whisker plot, can tell us about how our dataset is distributed. It is very helpful in determining the outliers in the dataset. The box represents the interquartile range. The line in the middle of the box is the median. The end lines are the first and third quartiles. The diamonds show outliers. However, we lose the ability to determine the shape of the data. A box plot takes the following arguments. Data. The data set we are plotting, like a data frame, list, or any array. X. A one-dimensional set of values like a series, list, or array. Y. A second set of one-dimensional data. Violin plots provide more information than box plots because instead of mapping each individual data point, we get an estimation of the data set using the KDE. There are two KDE plots that are symmetrical along the center line. A white dot represents the median. The thick black line in the center of each violin represents the interquartile range. The lines that extend from the center are the confidence intervals. Just as we saw on the bar plots, a violin plot also displays the 95% confidence interval. The cat plot function is used when our main variable is further divided into discrete groups. It can be categorized by three families of axis-level functions, namely scatter plots. These include strip plot, swap plot, distribution plots, which are box plot, violin plot, boxen plot, estimate plots, namely point plot, bar plot, count plot. This is how a cat plot looks. It shows that data of total bill is generated more on weekends. Python Seaborn allows you to plot multiple grids side by side. These are basically plots or graphs that are plotted using the same scale and axes to aid comparisons between them. We can use facet grid function to plot these graphs. Multiple histogram of sepal length category is plotted using facet grid for comparison. We can analyze from the result that distribution of species Setosa and Virginica is not normal, whereas species versicolor is almost normally distributed. Python Seaborn.set function can be used to display the plot in different background style. There are 5 preset Seaborn themes: dark grid, dark, white, and ticks. They are each suited to different applications and personal preferences. The default theme is dark grid. We can also remove axis spines from the charts. The Seaborn function spine can be called to remove them. Seaborn offers a lot of opportunities to customize your plots and have them show a distinct style. The color of your background style such as lines and ticks, and the size of your font all play a role in improving legibility and aesthetics. Data visualizations using Python libraries are quite handy and easy. Let's practice. Hello folks, in this lab we will be taking the visualization tutorial ahead and understanding the Seaborn API. We recently covered Matplotlib API that is proven to be an incredibly useful and popular visualization tool, but developers often encounter several problems. Matplotlib's API is relatively low-level. Doing sophisticated statistical visualization often requires a lot of code. Matplotlib was developed way before Pandas and thus is not designed for use with Pandas data frames. In order to visualize data from Pandas data frame, you have to work around to get into the right format. The solution to this is Seaborn, which is built on the top of Matplotlib. The main idea of Seaborn is that it provides high-level commands to create a variety of plot types useful for statistical data exploration. Let's take a look at a few of the data sets and plot types available in Seaborn. Note that all of the following could be done using raw Matplotlib commands, but the Seaborn API is much more convenient. Often in statistical data visualization, all you want is to plot histograms and joint distributions of variables. I have already imported Iris dataset and Seaborn library along with Matplotlib. In Matplotlib, you can create histogram like this. This shows the distribution of data. It is slightly positively skewed. This is how you can create histogram in Matplot. But in Seaborn, this can be easily done in a single line. Type SNS, which is the aliasing for Seaborn, next call method displot and pass sepal length of the dataset iris.set bins to 20 and kernel density estimation to false. I will discuss about KDE later. Run the code and see this is the same visualization as we saw with Matplot, but see how conveniently it is done and the length of the code is minimized to a single line. Now set KDE is equal to true. KDE is a Gaussian camel density estimate. It is a way to estimate the probability density function of a continuous random variable. Let's learn scatterplots using Seaborn. The method is scatterplot. Scatterplot is the most convenient way to visualize the distribution where each observation is represented in a two-dimensional plot via x and y axes. The plot shows the relationship between the sepal length and sepal width in the iris data. Let me make it more informative by setting colors of data points belonging to a particular class. Add a hue parameter to the same code and set it to a class feature. Run the code. Now the visualization explains that setosa can be easily identified and has small sepal length and width, whereas versicolor and virginica are intermixed with each other. This gives us better visualization than the previous one. Now I'm going to discuss pair plot. A pairs plot allows us to see both distribution of single variables and relationships between two variables. Pair plots are a great method to identify trends for follow-up analysis and fortunately are easily implemented. Call the pair plot method and pass iris dataset to it. Set hue to class to differentiate data points of different class from each other. Size is now deprecated. Set it to height. The pairs plot builds on two basic figures, the histogram and the scatter plot. The histogram on the diagonal allows us to see the distribution of a single variable, while the scatter plot on the upper and lower triangles show the relationship between two variables. We can observe the variations in each plot. The plots are in matrix format where the row name represents x-axis and column name represents the y-axis. The diagonal plots are kernel density plots, where the other plots are scatter plots. Except data, all the other parameters are optional in the method pairPlot. Coming to line plot, Seaborn line plots depict the relationship between continuous as well as categorical values in a continuous data point format. I'm dropping non-numeric column class from the dataset. So this is the line plot with legends. See the spikes and continuous nature of line plot. Sepal length has high values as compared to the rest of the PF features. Now let's move to violin chart. It is a method to visualize the distribution of numerical data of different variables. It is similar to box plot but holds more information than the box plots, such as giving more information about the density estimates on the y-axis. They are less popular. Here, you see the violin plot for three classes. The fatter area have more data points. For Setosa, we have a higher density between 5 and 6. That is very significant because, as in the sepal length, a mean value is at 5.43. Now coming to box plot. A box plot shows the distribution of quantitative data across a categorical variable and is used to clearly see the outliers in a dataset. Copy the cell, paste it here, and instead of violin plot, call box plot. In the plot, the quantitative data that we have used is the sepal length, and we are comparing it to the categorical variable class. You can see the median value, interquartile ranges, and outliers. We have outlier values in the Virginica species. Isn't it amazing that one simple line of code gives us this entire plot? Now I'm going to introduce another data set of a restaurant that shows billing information and tips given by customers in a particular time. The customers are differentiated on the basis of smokers and non-smokers. We have gender column as well. Now remove the unwanted column. Okay, now we can use it for visualizations. Here, I'm going to call to facade grid to show the percentage of tips. The facade grid class is useful when you want to visualize the distribution of a variable or the relationship between multiple variables separately within subset of your dataset. A facade grid can be drawn with up to 3 dimensions: row, column, and hue. The first two have obvious correspondence with the resulting array of axes. Think of the hue variable as a third dimension along a depth axis. The main approach for visualizing data on this grid is with the facade grid map method. Provide it with the plotting function and the name of variable and the data frame to plot. Let's look at the distribution of tips in each of these subsets using a histogram. Here, we are interested in the tips given by males and females. Next is factor plot method. It is used to draw a categorical plot onto a facade grid. Factor plot is informative when we have multiple groups to compare. Okay, now, factor plot is changed to cat plot. On Saturday and Sunday, both genders have given same amount of bill. On Fridays, males contributed more. Now we are interested in how many males and females gave billing amount, so we are using count plot. See, the major contribution is from the male customer. We have swarm, joint, rel, implots too. You can try them at your own end. Congratulations, you have finished the Seaborn tutorial for beginners. It's time to further explore and answer some additional questions that may help provide further explanation for Titanic data analysis. We have already performed analysis over it in section 7. Now it's time for visualization. So despite the differences in the characteristics between women and men determined earlier, what is the effect of age on survival rate? What is the effect of siblings, parents, and socioeconomic status on survival rate? We already know the survival percentage, which is 38.38%. Let's begin with finding total number of people who survived the Titanic tragic event. Out of 891 passengers in the dataset, only 342 survived this tragic event. Let's move to age factor. Let me plot a facade grid as we discussed earlier to display age distribution of survived and non-survived passengers. Run the code. So it looks like age distributions are not the same in the survived and not survived subpopulations. Indeed, there is a peak corresponding to young passengers that have survived. We also see that passengers between 60 to 80 have less survived. So even if age is not correlated with survived, we can see that there are age categories of passengers that have more or less chance to survive. It seems that very young passengers have more chances to survive. Let's look one for time. With setting hue to survived, it shows the probability distribution. Again, we see that aged passengers between 65 to 80 have less survived. So, from above visualization, we can infer that young have higher chances of survival. Now, let's check the survival chances according to gender. Type sns.countplot parenthesis open x is equal to sex, comma, hue is equal to survive, comma, data is equal to df, parenthesis close. From the above visualizations, we can infer that females were given more priority in the rescue operation. Almost 75% of females survived the tragedy. Now again, plotting the facade grid. From this visualization, we can conclude that men roughly had a higher chance of survival between the ages of 18 and 50 years old. Women roughly had a higher chance of survival between the ages of 15 and 50 years old. Now, let's take a look at the relation between passenger class and age. sns.boxplot parenthesis open p class comma age comma data is equal to df parenthesis close. Here we can get some information. First class passengers are older than second class passengers who are also older than the third class passengers. We can easily visualize that roughly 37, 29, 24 respectively are the median values of each class. The strategy can be used to fill age with the median age of similar rows according to P class. Let's try to find out whether gender of a person contributed to its likelihood of survival. First, generate a crosstab result between sex and survived class. Out of 891 passengers, we have a total of 314 females, and majority of them survived. However, we have 577 male passengers, and their survival count is poor. That is, only 109 survived. Now, let's visualize it using a stacked bar plot. Here, I'm using Matplotlib magic function and setting the kind of bar to stack and colors to red and blue. Run the code and you can see clearly that although female passengers are less in count, but they had a better survival rate than the male passengers. So, gender of a person is a very important parameter if we are computing the likelihood of survival. Let's figure out whether class of a person contributed to its likelihood of survival. Here, Class 1 indicates people belonging to the upper class of the society. Class 2 is the middle class, and Class 3 is the lower class. First, let's plot a bar plot. Type sns.barplot parenthesis open x equals to p class, comma y equals to survived, and comma data is equal to df parenthesis close. Also, set the title to class versus survived. Now, display it using the show method. It shows that passengers of first class have a higher survival rate, although the majority of the passengers belongs to the lower class. Now again, generate a facade grid. Also, the distribution of age can be seen clearly for each passenger class according to the survivor class. Let's see count plot for passenger class setting hue to survived. By the above graph, we get to know that people belonging to the upper class of society survived more than people of the middle and lower classes. Let's summarize things together using subplots. Let's find out the exact number of people who survived on the basis of class. Here, from this code snippet, we can visualize plots that show count of passengers in each passenger class and the survival count according to passenger class. Now, group the data set by P class and survived and then unstack them. So now you can see the count in tabular form too. So, survival chances were very poor to the lower class passengers despite their high count. Now let's generate a heat map over it with annotations using Seaborn API. It helps in determining if higher class passengers had more survival rate than the lower class ones or vice versa. Class 1 passengers have a higher survival chance compared to classes 2 and 3. It implies that P class contributes a lot to a passenger's survival rate. Moving on to SIP, SP, and PARCH. These two columns signify the number of relatives a person had on Titanic. Thus, it would be better that we make a new column relatives out of SIB, SP, and PARCH. Now let's visualize the impact of relatives on the survival chances. Run the code. It shows the survival chances were more if you have relatives support for both males and females. To make it more visually appealing, I'm adding aspect to 3. This shows that while there is a higher chance of survival for men between 1 to 3 relatives and lower in the case of having none or 6 relatives, women have a higher chance of surviving having relatives between 0 to 4. So these are the visualizations over Titanic dataset. So coming to the conclusion of EDA and visualization. It appears on average, women were more than 3 times likely to survive than men. Due to the binary nature of the survived field type, we can conclude that 75.3% of the women from the dataset survived, while only 20.5% of the men survived. An explanation for the higher survival rate among women may be the woman and children first code of conduct that has been strongly associated with the Titanic. There are important limitations of the conclusions on this analysis. One, for instance, is that data was only collected on 891 of the 2,224 passengers on board the Titanic. Thus, results of this analysis can only be attributed to the passengers in that collective sample. For future enhancements, we can work over some unexplored features. Of the many other characteristics left unexplored, passengers' cabin location is of particular interest. Due to the data wrangling, we determined 687 of the passengers did not have a cabin location in their data profile, because it is likely one person had booked the cabin for many passengers, that is, their relatives. Correlating other data such as last names may help provide information of the cabins for some of the other passengers. Being able to map passengers to their positions on the ship via a scatter plot may provide interesting results as to whether the passengers were in their cabins at the time the ship started to sink. Further data gathering of the cabin number to the location on the ship is needed to substantiate this analysis. Although this analysis gave us a clear picture of the main factors contributing to the survival of the passengers. Hope you like it and understand it. Hello friends, as we are done with all the lectures, now it's time for a capstone project. Today we are going to explore and analyze fast food restaurant dataset and visualize its results. Seaborn and Matplotlib for visualization and Pandas profiling to generate data profile report. Now, import the dataset using Pandas read_CSV method. Okay, I want to explore the top 5 observations of my dataset. So here are the top 5 rows with all columns and corresponding values. Next, move to EDA process. The pandas info and shape functions are normally used as a first step in the EDA process. Let us examine the available dataset. So using df.info, we get the result that shows we have 13 columns and more than 75,000 entries. We have 6 features that are of integer data type, 5 to float, and 2 to object data type. From it, we can see that we have no missing values. Now, let's find the shape of our dataset. Also, from this analysis, we can see that we have no missing values in our columns. No next move to the shape property. It tells us briefly that we have more than 75,000 rows and 13 columns in our dataset. Now, to only get the name of your columns, we use the name function. So these are your column names: item, date, quantity that is sold, unit cost of each item. Next, we have basic cost, the delivery cost associated with it, if any. Then we have the net cost associated with that item. Then we have a basic selling price. There is a feature called discount, and next we have the selling price of the item and the cash received. This is the profit feature. Next, I use the isNull method to find out the number of null entries, as we knew from our previous analysis that we have no null values in it. But we can use this function on other datasets to find the count of missing values in each column. Moving on to the type of statistical data in our dataset. So, using the same code as we did in section 7 here, I'm going to find out the type of my data. So, this is the list. We have only 2 categorical features, and the rest of them are of numerical data type. You can also summarize the results using the describe function. So, this is the statistical analysis of numerical features. So this is the mean value for each column. This is the maximum value that is present in a column. And these are the 25, 50, and 75 percentile values from which we can get interquartile range. Next, we can also find the statistical analysis of categorical values, for example, item and date, using the parameter include and describe function. So we can see that we have 21 unique items and more than 1,000 unique dates. But the most frequent item is the Zinger combo there. That is, it has occurred more than 8,000 times. And the most frequent order to date is 25 of February 2013. Now, let's find the unique items in our dataset using the unique function offered by Pandas. So here is a list of unique items. In my column item, we have 21 unique items that are offered by this fast food restaurant. We have some duplicate entries in item due to white spaces. Let's strip it using strip function. Now, unique items are 19. Well, let's find the correlation among features using the correlation method. We already knew that the correlation values lie between -1 to +1. So if a value is greater than 0.5, either negative or positive, then it means that it has a strong correlation. If the value is negative, then it means it has a negative correlation. So we can see that basic cost has a strong correlation with many features. So you can find the correlation among a different feature using this method. Now, time to visualize the correlation using a heat map. So this is the heat map, and it shows the significant correlations among different features. Now, moving to the profiling. Profiling is a process that helps us in understanding our data, and Pandas profiling is a Python package which does exactly that. It is a simple and fast way to perform exploratory data analysis of a Pandas data frame. The key advantage of producing a report as output with data profiling results is that it can be used later in discussions and taking decisions regarding data quality, data transformations requires, and features engineering for further visualizations and modeling. So let me show you the Pandas profiling report. This is the profile report generated by Python. It says that we have a total of 13 variables and more than 75,000 observations in it. And we have 10 numerical and 3 categorical variables. It also says that it has no missing cells in it, and we have too many duplicate rules in it. Moving on further, now it shows the variable and basic analysis. So an item is basically a categorical data type, and it has 19 unique values, and it has no missing value. Also, the top selling items are Midnight Deal, Zinger Combo, followed by Bucket of Fries, Hot Wings, and Extreme Box. Next, we have Date, and the unique dates in the whole data set is just more than 1,000. So these are the most frequent dates in which any order is placed. Next, we have Quantity, which is a real number. So these are some statistics related to it. So maximum is 45 and minimum count 1. Next, we have unit cost, which is also a real number. And these are the statistics of unit cost. There are 38 distinct values in it, and we have a minimum of 0 value in it and a maximum of 16,000 in it. We have a mean value of around 438 rupees. Similarly, you can explore basic cost, delivery cost, and that cost selling price discounts, tax cash received, and profit. So let's move to the interaction. So it is the interaction between quantity and quantity. You can select quantity with the profit. So this is the relation and between unit cost and the profit. This is the Pearson R correlation diagram. The darker area suggests that there is a strong correlation between features. We have no missing values in any column. This is the simple of first 10 rows. These are our last 10 rows. Next, we have a list of most frequent values, or you can say duplicate entries. This is the basic profile report from where you can get the overview of the dataset. Now, let's get back to our code. So, these are our columns. Now, from date column, which is in the DDMMYY format, I want to extract year and month for analysis. So now I have created a new column year, and extract year from the date column. You can do the same thing for the month column. Use the head function to see the result. Next, drop the date column as it is no longer of use. Let's find unique years. So we have 3 unique years: 2011, 2012, and 2013. Okay, now I applied function on the tax and cash received column and rounded off their values to 2 decimal places. Now, see, values are rounded off. Now, counting the occurrence of each item using size and using group by method. So, boneless box has been ordered 1,519 times. See the amount of Zinger combo extreme box ordered. Next, use Seaborn count plot to visualize it. From this, we can clearly see that Midnight Deal, Bucket of Fries, and Zinger Combo are top selling items. Now, I want to find the item ordered each year, so group the item year-wise. Similarly, you can find the quantity of items in each year too. Next, visualize the result using bar chart. Most items are sold in the year 2013, and the least order has been placed in the year 2012. We also use the value counts function to count the number of items, and it shows results in descending order. We can also use the n largest method to get top n results. Here I passed 5 to get top 5. You can use any number. Now I want to show the prominent items sold over these years, leaving the rest using a pie chart. So first, save the values after top 5. Next, save the top 5 values. Now convert them into a data frame. Now visualize it using a pie chart with annotations on. This shows the share of prominent food items. Now displaying only top 5 items in a pie chart. You can also save image using savefig method in png.jpg or other allowed formats. Now coming to boxplot. Here it shows the median value of each features. We also have some outliers in the profit of different items. Next is the crosstab. Here we can see the individual quantity ordered for different items and their total values. Boneless box is ordered once for 111 times, and so on. Next are the year-wise item quantity orders and the profit incurred. Moving to distribution plot of profit. It is positively skewed. Now, time to visualize results. The bar chart displays individual year-wise sale of items. Zinger Combo, Midnight Deals, and Bucket of Fries are hot favorite items throughout the years. Next, reduce the data set by extracting few relevant fields and creating a new data set and a plot pair to plot to see relationship between them. Year has no correlation with any feature as expected. Discount and selling price have positive correlation with profit. Now, summarize the result to get a conclusion. Here is the year-wise quantity sold. There is a minor decline in the year 2012 and major profit incurred in the year 2013. Next is the year-wise profit, and we see a decline in the year 2012. Visualizing both things together. Now, calculating the overall profit incurred in 3 years, which is more than 90 million rupees. So, this is the analysis and visualization of fast food restaurant dataset. You can further explore it using other features like discount, text, etc. Hope you enjoyed the course and learning. Thank you.